now. All right, our live stream is live. I'll just put it in all the usual places. Nope, I've just managed to not copy that over correctly. Okay, now pop that onto Facebook. And pop it up on LinkedIn. All right, I have popped it up on the various social media sites. So I think we're about ready to start. We've got a few less people here. We often have a few less for the last evening session, Sunday evening. So luckily it all gets recorded, so you get a lot more people viewing the video later than we get live. So we don't go too late. Shall we ready to get started? Sid, are you about ready?
Yeah, I'm ready. Should I share my screen?
All right.
Now?
Indeed, you see, I'll just start recording and then we can share your screen. If ready, you can start recording as well. All good. Over to you, Sid.
Actually, wait, I think I need permissions again, perhaps?
Ah, sorry, Randy, I'll just fix that up. Great, you should have permission to record there now, Randy.
Yep, got it, great, thanks.
Great. All right, over to you, Sid.
Oh, great. So I hope everyone can see the presentation now. Is it visible?
Yep.
Okay, great. So sounds like we can start. So hi, everyone. So this is an update on the DroneCam work that has been ongoing recent in the last year. So we'll start on the 1 second. Seems like, oh, hold on.
Yep, you're fine. We can. Are you not going to the next slide? What's the problem?
Yeah, it's something related to the window has stuck for some reason.
All right.
Hold on.
No worries.
I'll just start it again.
Sure.
So, all right. Cool. Yeah. So this is an update on what has been going on DroneCam and CAN in general with regards to ArduPilot and general like UAV CAN, DroneCam ecosystem. And we will do a brief overview to start with and see, what are the things we are going to talk about. We're going to talk about how CAN actually works. Most of the people are already aware of certain of the key points on the operation side, but I think it's good to at least have some base before we go dig deeper onto how DroneCam works and what are the features that we'll be introducing over time. And then we are going to talk about DroneCam, how it came to be, what is the purpose of DroneCam, and what the future looks like for DroneCam, right? Then we are going to talk about what has been done in the past year on the DroneCam in terms of features and improvements and the support related things. And then the features that we are actually developing right now as we speak, and then what the future features are going to be for DroneCam, right? So let's get started. First, the brief introduction. So basically, the history is Bosch came up with the idea of using campus in the automotive industry in 1985, and then that bandwidth was not big enough, and for new technologies like new sensors that have been coming into the industry, so they thought, let's introduce CAN-FT, and that was introduced in 2012. And even like 2 years after that, we saw the use of CAN in our drone industry. We saw that this I2C lines flying all over, serial lines, just big mass of different protocols just doesn't make sense. So we need a unified transport layer where we can talk to all the intervehicular peripherals, right? So just CAN sounded just the right technology for that, and it is. And we have seen just a huge ramp up of the users and the even the hardware manufacturers adopting this technology. And then great thanks to the UAV CAN development that came around into 2015. Back then, nobody was even aware of, not many people were even aware of 2015. I recall Trid just pinging me late 2015, are you interested in working in some CAN GPS? I just slightly recall that, and that's where it was, just very, very early stages of development, not much done there, and just hands of few people just tinkering with it. But now it has matured to a big project and has a lot of users and actual hardwares from big to small industries just flying all over the world, right? So this has been a huge turning point. I think I would say the last 2-3 years for the UAV CAN development and adoption. People have really seen the value of using this technology, and I think it is quite awesome to this big. So let's talk about CAN network, how it works and what are the benefits of using it. Right. So you have this on the left hand, you can see, without CAN, and on the right, you have with CAN, right? So without CAN, you have these, different protocols, different number of wires, different type of technologies, just, zooming across the whole area just to communicate, basic messages, right? And there is no smartness there, right? You have just utter complexity all over the place, right? And still, after even having these many lines and these many connections, interconnections, you're not getting that level of reliability, because most of these protocols operate on your single line interface. There is no differential line, right? So it is not even that noise tolerant, and not even reliable to that extent for the amount of wiring and connections that you are doing. So it seemed just nice to have this kind of network where you can just run one line, two pairs if you want, redundancy, even 3 now. We have support for 3 CAN buses in ArduPilot already. So this line you have to run just through the entire drone basically, and that's it. You can communicate to your ESCs, your servos, your lidar, your GPS, compass, whatever you have attached to your drone, all on single bus, right? So that is a huge advantage of CAN, right? Just reduces the number of lines that you have to drive through the entire vehicle. So that reduces complexity, and also of course makes the vehicle lightweight. Then how does it achieve the reliability? I think that is a very interesting way the CAN deals with the conflict. So basically, even the Ethernet network doesn't have this proper conflict resolution at the transport layer, right? But the CAN comes with it at the transport level. You do not have to write an application layer, or you do not have to write any network layer to actually deal with the it has the message arrived. You do not have to ask that question. It is known by each and every node if the packet made through or not, and they can, resend it as soon as it fails. So you can see here in CAN terms, you have something called dominant and recessive, right? So if you see a line high here, that means dominant, and the recessive means that's low, right? So there is this four nodes are trying to communicate packet at the same time. You can see here, right? Sorry, three nodes are trying to communicate their packet at the same time. And there is this arbitration part where the arbitration happens. And as you can see, until bit 6, there is no conflict, everything is going smoothly. And then there the arbitration happens, and you see that node 2 basically goes out and says, yeah, it's not my line, and lends the line to node 1 and 3. And then node 1 also goes out and just lends the line to node 3 to communicate the information. In this particular case, node 1 and 2 are aware that they failed to communicate this message, and they can transmit as soon as the node 3 finishes. So this is a quite useful, technique that CAN uses to just pull the efficiency out of that network. Even when you are at the peak network usage, you're not dropping packets. You are just using it super efficiently because of this technique, right? Another quite nice feature of CAN network is that it is quite error state aware. So whatever error is happening, not just the node itself, it makes everyone on the bus aware of that error using error active frame. So basically, if it is in, if the counter hasn't reached certain set point, it will, if it receives an error, it will send an error frame that everyone else can review and generate even their own error frames, so that it actually makes sure that everyone is aware of that there has been an error that has happened, and it's time to maybe be quiet, or if you want to specifically handle this error in some way, say you want to return home, you can do that with CAN bus, right? It is not a feature of even serial or I2C. If packet is lost or corrupted, you are just left in the water, dead in the water. You're not aware of if it has happened or not, unless you have attached additional layers to it in terms of CRC or some other types of error. So these are the types of errors that it can detect, and based on that, it can generate an error frame and let you know. There is also an error passive frame. So basically, if you have an node that has already entered a deep error, that is, it has reached that counter of 255 in our case, and after that, it basically just sends the error passive, right? So it doesn't bring down the bus. It just sends this message if only if the master node is looking for that particular message, it will be able to see it and find out which node is failing, right? So another key point of CAN network is differential signaling. So compared to other signals like your I2C, SPI, serial, which all work on single-ended system, basically you have only low as ground and high as minus 3.3 volt or your 4.5 volt or whatever. It does not, the noise characteristic of that particular system is has a lot of issues. Your ground might not be level everywhere, right? Your there can be magnetic interferences on the way, which can screw up. For instance, it happens with PWM a lot of the time, where you have this long PWM lines running and you have some motor or some actuator on the way just corrupting that PWM line. That is a thing which this differential signaling can improve quite a lot. It cannot improve almost like proper, like effectively, but even if it fails, as we saw, there is this error resolution, so it will try to send it again. So your message is going to make it. This is what CAN network ensures. And even at the the bottom level of transmitting on the wire, it uses the best technology there is without having more complex systems on the way, which is as simple as differential signaling to achieve the best possible outcome here, right? So this is how, like, the key features of CAN network, and this is why we like it. This is why we want to use it in our drone systems, which I think it is becoming more and more relevant for it to be safe, and more and more relevant for it to be robust when you're flying it, right? So please feel free to ask any questions along the way if you have any. So I'll continue. So this is another point that I want to discuss. I think this is some of these points are not relevant now, as because we haven't we haven't gone to that scale for the 1 megabit line, but for the 5 megabit line, we will be reaching that stage, right? So the common mistakes that we do on when setting up the node CAN network is people are not quite aware of the CAN termination, that they need to terminate the CAN bus. They don't measure the resistance, and that it should be above certain ohmage. If it is not, then it will create issues. So this R term that you see, you are supposed to, if you are living in the perfect world, have 120 ohm connected at each end, and the total bus should not be the ohmage should not be less than 45 ohms. So this is how it should be set up. So please ensure that you are terminating your CAN bus properly. It is not an issue for short distances, but for long wires and if you have big flying wings and gliders, this actually makes a big difference. And you have to ensure that you properly terminate your line, so that otherwise it will create issues. And
I almost wonder, Sid, if we should actually have some way to measure it in software. Is it doable for us to actually have, like, some of the nodes, like the Here Pro or something, actually be able to measure what the resistance is?
That is a nice idea,
really.
actually, but it will be like require an additional hardware. But I think what can help is having an ability to switch the turn the terminating resistors on and off, right?
Okay.
That is a feature that a lot of our hardware, at least from QPilot, that will be coming from now on forth, will have that feature that you can turn on the terminator resistors on or off based on your network. So if you first set up your network, you realize which particular device is sitting at the endpoints, and you put the terminator, turn the terminator on at those ends, right? Another idea could be we actually have, people can have actually external terminators, so they can have like just a simple knob that has this 120 ohm resistor. Just stick it at the end and turn off all the terminator resistors inside the modules itself, right? So that is, I think, but for now, from what my experience and my use cases have shown, I think up until 1 megabit, we haven't seen that much of an issue for short lengths. And by short lengths, I mean like below 30 centimeter, right? So if you are at those ranges, I mean, it is not that big of a deal. So the reason why this terminator is there is because of something called ringing. So you have this time delay. Basically, the signal gets reflected back, right, and causes the interference with the signal itself. And that is what we are trying to avoid with this R terminator. And if you have very short length of distance, the ringing is not going to be that impactful. But if you have long distance connections, it's going to be quite impactful. So for small drones, below 30 centimeter wire length, it is not that big of an issue. But as we increase the bit rate, this is going to cause huge issues, like 8 megabit. And if we reach those speeds, I mean, even the 10 centimeter line just doesn't work without termination. So that is going to be an issue. So people need to be aware of that as we move into the CAN-FD arena. And another thing that is quite important to know about CAN is that the standard that we are using is the high speed CAN, right? Not the low speed. So the low speed CAN, that 125 kilobit per second, that technically supports star topology. And the reason behind that is you don't want, single wire failure just bringing the whole network down, right? So that is more robust kind of network. So if you want that, you bring down the bit rate and you have this star network so that it is much safer to use. But the network that we are using is fast, high speed, CAN network. So if you are using, lengths, larger than 30 centimeters, you are not supposed to have that long stubs without termination coming out of the network. It can be really, really harmful to the quality and robustness of the bus. So if you are going beyond 30 centimeters, ensure that you follow the proper topology, that is the linear bus topology, and to basically improve the reliability of the network. So that is quite important here. And as we move to, again, with the CAN-FD, I mean, even for the small frames, you are going to be required to follow this kind of topology. Otherwise, you're going to see some issues. But again, need to do some experimentation, more experimentation to know what works with the CAN-FD. We are still at, I would say, testing and teaching age of the development. All right, so moving on. It's time to discuss DroneCam. So we are going to talk about what has happened so far in the DroneCam area. And the first point is, well, how DroneCam came to be. What is the reason behind DroneCam? Well, we already talked, UAVCam was there. What was the reason DroneCam was needed to be introduced? UAVCam was already present there. Well, the main key important points that we found with the continuation of the development, and I would say more like abruption of the development of UAVCam, was that they were trying to, the project UAVCam V1 was just trying to be, just start from scratch, right? Just throw whatever has been done up until now into the, fire and just start from scratch. Now that is a very bad deal for the people who came in at the early time, and this is quite disheartening for people who started early on the project, right? So they have to, like, basically their hardware might be rendered unusable. So that is something that is not very good for many of the early adopters of the protocol, right? So that is one point. Then we didn't see a quite clean migration from V0 to V1. There were ideas being thrown around, but they were just ideas, right? When you are bringing something new into the, into this protocol, you have to have that layer, set first. Like, this is the key core of the problem, then we build around it. But rather they were like, okay, we'll talk about it at later stage, but let's discuss, other things now, which I think was also something not that, nice about it. And I think we generally, at least I, observed a lot of complexity in setting up the node, and how the whole project was being driven. It was just this, there is a talk about, like, in the open source world, how you should develop a project. Should it be like like an open source, open to all, everyone can contribute kind of thing, or you should have this kind of cathedral model where people just work in isolations, and then they have this finished product they just show to the world. And I think ArduPilot and our community is more, I think, bent towards we allow everyone to contribute, right? We have these Discord channels where anyone can come and talk about it, discuss things, and everything is done in the in front of the world, and that is the sort of model that I think we like. I think probably Trish will agree, and that is one another reason I think that this DroneCam was built upon, is to continue that with UAVCam V0 and make it, improve it, and make it in a way that it is it increases the adoption rather than discouraging people, that have already adopted, right? So these have been the key points that at least I would say I observed during the UAVCAN discussion, UAVCAN V1, V0 discussion, and ArduPilot and PX4 basically agreed that DroneCam can be a protocol that can be used inside the for the inter-vehicle communication, and we can continue the development of what has already been done and evolve it and make it even more mature and better suited for the application. They have been long. I think one can probably write a book on it, the level of discussions that Pavel and Tridge had on this topic. And I'm not sure if it is even available public right now, but yeah, it was just a long and a huge amount of discussion before we came to this conclusion. So yeah. What are the goals of the DroneCam project? And we want to make sure that DroneCam basically is basically a follow-up of UAVCAN. Sorry, not a follow-up of UAVCAN, but a continuation of UAVCAN V0, right? We don't want to just reinvent the wheel again. We want to continue what has already been done, evolve it, mature it, fix all the issues that we found were there, and there were issues, and I think a lot of them are fixed, but we are going to continue to fix them. There are some messages that were written, at the earlier stage, and people kind of adopted them, but they were not, better, well-formed messages. There was just so much, stuff that we didn't needed, and so much stuff that it didn't contain that we needed, and that has just led to this fragmentation of, like take GPS message for example, like you have this fixed to message, then you have fixed message, then you have status message, then you have just a huge, melange of just to get a simple information that, even uBlocks a message that does it in a single message. We are just using multiple messages for that. So that is just not viable. And I think as we move forward, we are going to update a lot of these message sets. And most of them do exist in the sensor. I believe the sensor messages are the ones that have this kind of lot of fragmentation. And I think as we add more and more features like extensibility and node capabilities, we'll be able to phase out some of these messages and allow for better messages to emerge from this. So I think that there is a nice clean roadmap that we see that we can achieve this, and I think that will be great for the community. And while we do this, we do not break the existing system. That is very, very important, because if you break what is already there, that will turn away users and the manufacturers. We don't want that. We want people to accept more, adopt more, rather than lose the people who have already been adopting it for years now, right? We want to, develop the tools that are needed for the DroneCam development and make it super easy for people to just, okay, this is the parameters you need to set. You click the button, your network is set up, right? It should be that easy. And we have for the ArduPilot, I would say we have done it quite a lot already. I do think that we should probably enable CAN bus on all of the hardware by default now. I think it is now high time that it should not be an option that people need to go in and select that I want to enable UAVCAN. I think it should be enabled by default now in a lot of the boards. So
that's an interesting idea, actually. Yeah. The things like GPS type auto, should it just should CAN GPS be included in GPS type auto? Currently, it only does a couple of the serial ones.
Right. I think
we need to think about
The reasoning behind that was like what happens to the people who were using the previous kind of, as we said, like they had set up, they were aware of this way of setting up, the changing it upon them might not be a good idea. But I think now that we have GPS ordering, I think this was a decision that was made because of the ordering issues. But now that we have GPS ordering, I think it might be time to basically turn this as an auto detection scheme so that people don't use that much.
Probably on F7 and H7, maybe. But we'll need to sort of do some experiments and see if it's going to break people's setups. F4, they're often low on RAM.
Yeah.
Like the F427 is often very close, and you turn on CAN, it may not, other core functions may no longer work. F7H7, yeah.
I think
I think it's worth investigating.
Yeah, I think it's now time to enable it as a default option now. So bring the basically setup for the UAV CAN even lower. That would be nice. So yeah, we have this. We also want to develop a very nice application layer. Like basically you have this libuav CAN setting right now, but it is just so complex to use, and it has so many so much space that it consumes. I think a good replacement for it is very, very important, and I think that is also one of the key things that will be part of this development. Right. So how the DroneCam project is run? So currently it is being run under the auspices of ArduPilot organization. It's funded by ArduPilot wherever required. It's maintained by Tridge, myself, and Daniel Agar from the PX4 community. So the Discord group that is being used is free for anyone to join. You can visit this website, dronecam.org, get the link to the chat, join. Everyone is welcome to discuss and talk about the future of DroneCam. We welcome discussion and contributions to that end. Right. These are the DroneCam supporters, the people that have joined the community, the company, sorry, that have joined the community to provide support with the development, and most of them are users of our hardware itself, or some of them are consumers of our hardware. Right. Let's talk about what are the features that we have implemented in the DroneCam by far. So now we have support for CAN-FD in ArduPilot, of course. I'm not sure if the PX4 has gone towards implementing this part, but ArduPilot has that support. We have written the driver work. We have done that work for all the modules that are needed to be updated to support CAN-FD have been updated. You have this scanner, libuav CAN, Python CAN, GUI tool, all have been updated to the point that they can receive and understand CAN-FD frames. I would say that at this stage, CAN-FD is as functional as the normal CAN in terms of the tools. All the features and stuff that has been supported by CAN 2.0 transport layer are now supported by CAN with CAN-FD as well. Even the CITL now is able to communicate over CAN-FD. So this can be quite handy as we move towards more and more CAN-FD related development. So we can simulate it and understand what needs to be done. There was some. So currently we only support STM32H7 chip in the master. So it has still not made to the stable release. So it's still in master. I think the reason was that we felt like node capabilities is also something that needs to be there to make it actually usable. So I think the call was made that STM32H7. The call was made that it should just stay in master, and until we have all the bring up stuff done, we don't let it go into this table. So right now only STM32H7 chip is supported, and we plan to support G4 as well. There have been some clock config related issues with the G4 when setting up CAN. We still need to debug that. I have ordered the G4 dev board. It's on its way, hopefully to reach me, and I will be able to do that development. So yeah, right. So what does CAN frame look like? So of course, this is just the frame part of the initial header part of it, which defines it to be a CAN-FD or CAN frame. So you have got this, if you look at this, the framing, the biggest difference you see is this BRS bit, this addition of BRS and ESI, these two bits. And this is what is differentiated from the normal CAN frame. So BRS basically means your bitrate switching, which allows CAN FD frames to be transmitted with two bit rates. So basically your arbitration phase will be transmitted in say 1 megabit, and the data phase can be transmitted at 8 megabit. So what that allows is for nodes, there are actual some chips in the market as well that are not able to do off to CAN FD frames, but are capable of understanding that it is a CAN FD frame and generate a blank data phase, so that the normal CAN node doesn't go into an error state. So this basically allows for a very nice movement from CAN to CAN FD. And if you have CAN and CAN FD both supported on the same bus, you can actually have both types of communication going on the fly. So you can actually use the same bus to decide if you want to go into CAN FD or not. Basically, by asking everyone on CAN bus, the normal CAN, if they are able to do CAN FD or not. We'll discuss that sort of feature that is under development in the load capabilities section. So this is one of the key differences. Another key difference is, of course, the DLC. So the CAN normal 2.0 is only capable of doing 8 bytes in the data packet, right? While CAN FD is capable of doing up to 64. The big difference is that the DLC bits that are used are only are the same. The size is same, basically 4 bits. So 4 bits are used to define 64 length, which means that there has to be some gaps, and after we count to 8, we have gaps of 2 to allow for incremental variation in the DLC, rather than having 1 to 64 nomenclature, which will require two additional bits, which we can't have. We only have 4 bits. Right, so this is an example of comparing your classical FD. So you have this classical CAN sending up to 8 byte, and in the same space, CAN FD is able to send 64 bytes, basically. Now, let's say if your classical CAN is operating at 1 megabit, and CAN FD with the BRS switching is operating at 1 megabit of header and 8 megabit of data, it can basically pack those 64 bytes in the same space as your classical CAN would be able to pack only 8 bytes. So it is like a 8x improvement in the speed. So that is quite useful when you are trying to transmit a huge amount of control data over the single or dual bus system, right? So these are the changes that we were required to do in CAN, or to basically make CAN FD work, right? So there is a feature in UAV CAN called trail array optimization, which means when you have an array at the end of the message, we don't mention the length of that array. We just get that information by looking at the size of the entire packet, and we kind of guess, okay, this much packet is done, so whatever is remaining is that array, and we just divide it by the array size to get the length of that particular array, right? This is all good and well when you have just increments of 1 in the data length. So 1, 2, 3, 4, 5, 6, 7, 8, you have this nice DLC package, you can do this. But as soon as you go to CAN FD, that is quite not possible, as after 8, you don't have this kind of flexibility, as 9, 10, and each and every increment does not represent the equivalent size in the number of bytes in the frame, right? So basically your 10 is not 10 bytes, it's just actually 16 bytes, right? So we can't use this kind of tail array optimization in CAN FD, so we are required to basically disable it. It is not very tricky to do that, because and whenever we are sending a CAN FD frame, each and every node is aware that it is receiving a CAN FD frame, so it can pass it as such. So this issue is not presented like in a way that it breaks any support. You can have both normal CAN and CAN FP operation on the same bus in the same drone CAN bus, basically. So all it requires is that awareness needs to be there inside the individual libraries like libuavcan and canard, so that they are able to know that this is a CAN FP frame and they need to handle it as such. And that is what changes that we needed to implement in each of the libraries and the code generators, so that we can pass on this information from the driver level. So driver can basically receive the packet, CAN FP packet, and when it's passing into the, say, canard, it can tell that it is packet. And when canard passes it for deserialization, it tells the deserializer that please disable the TAO, that so that it can be passed as such, and we get that information back. And same thing is done in reverse for the serialization. Of course, when we are sending a CAN FP packet, we have to be aware of sending. We can't make this call at the transport layer. We have to make it at application layer. We are sending a CAN FP frame, and then only it will be sent as such. Right. So we support BRS mode only. So right now we only support bitrate switching mechanism. The reason behind that is we still have a lot of CAN 2.0 nodes sitting around, and we need to ensure that they are able to get their messages across. If we go to the fixed high rate, say if the node is operating at only 8 megabit, it won't be able to listen to the packets originating from the old 1 megabit CAN frames, right? But if you have bitrate switching, it will be able to listen to the legacy nodes. So basically, your 1 megabit header, it will be able to tell that it is a CAN frame, and it will be able to handle it as such. So that's why we are going to keep BRS mode active only currently. But in the future, as we see more and more adoption, we can introduce a fixed rate support as well. So there has been some work was done to integrate DroneCam into CITL like about a year or two ago, and we have basically APPerif CITL GPS running on our CI, which checks if the CAN network is working or not using the socket CAN, and we have this basically added a support for CAN FP as well now. So you can basically transmit CAN FP frames over virtual socket CAN as well. So let me actually give you a demo on that, so that you can get a view of how basically it works. So right. So this was a PR that actually just recently went in, just a week ago, I think, a week or two ago. What we basically do is, so up until now, we were using just a standard CAN. The standard CAN doesn't just requires, I think, 16 bytes, I think, 16 as the setting of the MTU. And you can do that transmission only, a normal CAN bus. So what we have to only change that we have to make the CAN FP work is set the MTU to 72 because of the larger packet size that is required. So basically, the frames are now able to transmit over the CAN raw socket with the 72 MTU, and can be recognized as CAN FT. So all that magic happens on the Linux kernel end. It is part of the Linux kernel, the virtual socket, and you can use this to simulate a CAN FT network, right? So for example, you just run, so very simple steps. You run your CAN CITL nodev.sh. If you are using cancitl.sh, it contains, you can see the help. It allows you to actually connect a socket CAN onto your computer, and use that via bridge connection alongside virtual CAN. So you can actually add an external CAN module to your laptop as well, and use it for development if you want to, say add a support for LiDAR. You can just use SLCAN, use Cube or any ArduPilot running AutoPilot as an adapter for SLCAN and connect it and use it as using bridge. You can achieve a connection with your local SITL and develop the driver for it, or test it, whatever you want to do. For now, we only care about Node. We do not have any physical device connected. We just run this, and it basically kickstarts the Linux kernel to start the socket CAN network, and then we just start the Autotest2. Yes, Autotest, and we go. And let's also start the DroneCam GUI 2. So you can already see that VCAN 0 will just appear on this list. You can select that, and the node will just appear here, right? So I already set the parameters, I think, for the CAN-FD while I was testing. So let's see if it already has this. Yeah, it's already transmitting FD frames. So you can see that it can transmit CAN-FD frames over the virtual CAN, and it is, it is going through the same pathway, your libUAV CAN, CANARD, ArduPilot. So all of those code paths are being tested right now to check if the FD works, and can get this information right from this DroneCam GUI tool. So you do not need to have any other setups there. Other than there are some packages that you do need to install, which can be found under APPerif tools, APPerif README. So we have a very nice explanation inside the README doc to not loading. Anyways, so we have a very nice detailed information on how to use the virtual CAN to test various things. You can just read this README, and it will let you know what all we need to install and how to set up various things here. All right, moving on. So what do you require in terms of hardware for CAN-FD? So CAN-FD does not work with the legacy CAN transceivers. It requires some special transceivers that have support for CAN-FD, and some transceivers are also available in the market, which can basically at least blank the CAN-FD part, so that for the MCUs it looks like a empty CAN frame, and they can handle it properly, rather than going into an error state, which will happen if you send a CAN-FD frame to a node that does not support CAN-FD. Because as we saw, the framing is different, and the error that will be triggered is frame error, and the error will just keep incrementing until it reaches the peak, and it will just make the node go silent. But during that stage, it will generate error active messages, which can be annoying for the bus, and can bring down your the maximum bandwidth that you can reach, but it's not that much impactful for the current status of the network. You need to ensure that the bit rate that your transceiver transceiver you are attaching is supported, right? So you cannot run 8 megabit on a 5 megabit CAN transceiver. So basically, each CAN transceiver has its specified bit rates that it can support, right? So you need to be operating under those circumstances. Some of the CAN transceivers only support up to 2 megabit per second. Some are up to 5 megabit per second. Some are up to 8 megabit per second. Technically, the spec for the CAN-FT says it can go as high as 12 megabit per second, but there is no transceiver that supports that as of yet. It might come out at some point, but right now there is no such transceiver in existence. So CAN-FT is quite sensitive, as we discussed, with the network topology and the termination. You need to do all of that really, really properly. If possible, attach an oscilloscope to your network, see if the lines, the data that you are seeing on the CAN-FT is clean and nice. You don't want your network to be done in a way that it is not robust, because at the end of the day, this is aviation scope, so you need to be safe. And for that, you need to ensure that proper specifications are being followed and proper testing has been done. It is compared to can be slightly less robust, so you need to ensure that you have done proper setup. If you are testing things, you will, as I said, there is a good error state awareness in CAN bus. So if your network is not properly done, you will get error states, and there are ways to get to those states. Like I think Trish already introduced the access messages, so you can look at the CAN stats and CAN log to see what is happening in case your bus is not working properly, or even just to analyze if everything is going fine. So that is very, very important as we move towards CAN-FT networking. So moving on. There are more improvement, more features that have been implemented as we discussed CAN-FT, but there have been more stuff that has been ongoing. I think Trish already gave you guys a brief about the drone CAN over marbling. I think there was a demo as well. So basically, drone CAN over marbling now supports CAN and CAN-FT both. You have a choice to select a low bandwidth option, which is really cool, so that you can have actually drone transmitting its own peripheral status, health, and whatnot. You can even update the peripheral over the internet. Basically, you can connect the marbling stream, forward it to your servers, and you can control your drone's internal architecture even, which is really cool and handy, I think. So that has been a very nice feature, and for GUI tool, it's just as easy as marbcan colon port name. You can just go and connect that, and you will have CAN and CAN-FT working on your GUI tool even. So we have a new code generator. So the legacy code generator had issues, and there was a code generator that was written by myself and Jonathan Challenger even before the current CAN generator that was there. So we, I think, wrote it when there was no generator there in the first place. So at that stage, it was just done for the internal use. It didn't gain much ground. And as we were developing on the DroneCam, we found that the existing CAN generator had a lot of issues. And I figured that we have this robust code generator already lying around. Let's just use that. And I have modified it to basically have support for CAN-FT, and also added an auto test for each of the messages to basically serializes each of the message types and deserializes them to ensure that the messages are being generated and deconstructed properly. So that has been added now as part of the DroneCam project. We have a lot of GUI tool improvements. I mean, there has been I think every week there has been, almost every other week there has been a release of GUI tool now for the last, I think, couple of months. So there has been support for marbling, CAN over marbling edit, there's CAN-FT support. The size of the Windows build, which was in gigs, has been just reduced to a couple hundred MBs, which is, I think, still big, but I think compared to what it was, where it was before, is much better. There has been issues with regards to it running on macOS. and that has been fixed. It now supports APG and PX4 files to be used to upload into the before it only supported your .bin file. Now you can use these files to upload the firmware to the peripherals as well. There changes, I would highly recommend people to just update their GUI tool to ensure that they are using the latest and the greatest version of it, and ensure that you use the DroneCam GUI tool. I think the UAVCam GUI tool has not been undergone any development for almost more than a couple of years. So just ensure that you're using the right tools for the development. Right. Moving on. So now we have another topic called node capabilities. This is a project that is under development. So what we discussed up until now has been developed and gone into various repositories and have been released into the wild. But this is something that is just just started. I started working on this last, I think, 1.5 weeks ago. What is the need for node capabilities? Well, we have these new features that we want to bring in, right? But we do not want to break what is already there. We want to ensure that the update or upgrade is smooth and there is no, basically rendering the old stuff useless, right? How do we do that? So for that, we have introduced this node capabilities. Basically, you have this set of features that you can, tell, okay, I can, this features is something that I can support, nothing else. So please ensure that the bus is capable of supporting my of my node, right? So this is what the key use case of this feature is. And we have these features, as you can see, the FDCAN 2M, 4M, 5M, 8M support. So if you have multiple, transceivers all mixed together, we need to ensure that all of them are able to talk to each other. So we have to find the common megabit which it can support. So, and then there is support for, let's say we have the new libraries, all of them actually support selectively disabling the tail array optimization, which is not only useful for CAN-FT, but will be useful as we move towards the message extension as well. Because once you go into message extension, you cannot have tail array optimization. You cannot estimate the size of the array because it's no longer the tail, right? You have additional data coming after it. So we want to be able to disable that support so that we can support the message extension. So, and on top of that, we have support for DroneCam messaging level. So we want, as we discussed, we want to create better message sets, and we want to ensure that the transition towards the new message set is clean and robust. And to that effect, we have introduced this drone messaging level parameter, which every node can publish. Okay, this is the level up to which I can support, and we will basically the lowest of all basically will tell us, okay, this is, so if there is a legacy node, or it can just say, okay, I only support legacy messages, right? So we will just set it to that, and the entire bus will just follow this legacy level, right? There can be some nodes that pretty much don't care, as they are probably not even transmitting anything. Oh, sorry, not consuming anything. They are just sensors who are transmitting some data. So in that particular case, they can set it to don't care, as they don't consume any messaging level of message. So this message is still under development. We are still I think I'm yet to even discuss this message set with Fridge. So this is not even committed. So this is where I'm at with the development. So this basically will be the node capabilities message, and then you will have get node capabilities, which will be just a service request, a request that can be made by the master to request the node capabilities from each node that is on the bus. Right. So this is the flowchart of how the node capabilities master is going to operate inside this system. Right. So before we actually look at the node capabilities, we need to ensure that all of the nodes on the bus are healthy and operational. This is really important because a lot of the modules, they will be able to support the latest DroneCam or with CanFT or whatnot, but it is quite possible that they don't have a good bootloader, for example, right? So they are, when in maintenance mode, they might not be able to support the best capability that is the node capable of. So we want to wait until all the nodes that are appearing on the bus are healthy and operational. And if they are not, we generate an error. In ArduPilot case, it will be a prearm check, I think. So if all the nodes that are on the bus not healthy, we generate a prearm error that, well, this particular node is not healthy. Please either remove it, replace it, or update it, or whatever, or wait, basically. So this is still, we need to see how that works. We don't want to false notify users that your node is not working properly. So the messaging needs to be proper. So what if it is healthy? Well, if all the nodes that are on the bus healthy, we request node capabilities from each of the nodes that we see and verify. We have already verified. By verification, I mean we have already compared them against the DNA or dynamic node allocation array, that they are having the registered node IDs, right? So once that is done, we request those for capabilities. What are you capable of doing? And each of the node basically sends back the node capabilities message, which is not just listened by the receiver itself, but all of the nodes on the bus. And they can basically process it in a way that we get to the maximum number of the capabilities that all of the nodes are capable of supporting, right? There might be nodes that might not be able to even understand this message, as they are legacy nodes. For that, we will try 5 times. We can ask them 5 times. If they don't respond, we say that this is a legacy node, and we just have a constant called legacy supported node capabilities, and node capabilities that is supported by the legacy nodes. And we just use the minima of that and use that as the updated node capability for the bus. Right? Once we have resolved the node capabilities from all of the nodes, we now get into the step of actually configuring the bus to have this particular set of node capabilities. And if we are not able to do that ourselves, we raise an error in the form of prearm check again. But if we are able to switch to that node, we start publishing repeatedly that this is the maximum supported node capability at the same rate as node status, and all the listening nodes should switch to this particular node capability as well. And this is basically, we'll just go on and loop until we actually receive a message from a node which out of nowhere appears saying that I do not support this particular node capability. And in that particular case, if the capabilities are locked, and the capabilities could be locked, for instance, let's say we are flying, right? We don't want to switch bit rates mid-flight. That might lead to, say, crashing the ESCs if we reduce the bit rates too low and stuff like that. So we do not want to be able to change those things mid-flight. In that particular state, we will just ignore it. I think that is the best thing we can do there, and we will just keep ignoring it until we are back on the ground and disarm. We can potentially notify the user that there is a node present which is saying that it's not capable, and maybe you should return home or something. But I think my thinking is that it should just not ignore this particular change and move on. But if we are on the ground and doing nothing, and the capabilities haven't been locked, in that particular state, we just do the find the maximum number of node capabilities supported along with the new node, and we update our node capability and move on from there. So this is the current, I would say, a tentative structure of how the node capabilities will work. I think a lot of things will remain same in many form, but there will be some changes as we do more and more discussions around this moving forward. Right. Okay, moving on. So we discussed how the master or / authoritative node will work in this particular situation. We need to know how the slave nodes are supposed to operate like. So only reason the slave node should be publishing their node capabilities is either when they are requested by the master or they observe a node capabilities mask containing an unsupported bit. Only in that particular two circumstances they should be sending their node capabilities, in my opinion. For if a node sees that other node basically sending this node capabilities with a lower capability, they are supposed to downgrade their own capability and potentially publish as well. We can discuss that if that needs to be done or not, so that we create this domino effect of letting everyone know that you need to change your node capability. During the locked state, only and only authoritative node can command the node's downgrade. No one else can do that. No other node's message should be accepted in that particular situation. And upgrade can only happen when authoritative node asks. Even when in unlocked state, a slave node cannot tell authoritative a network to downgrade the node capability. Now we select if the node is authoritative or not based on this flag. Basically, if you are an authoritative node, you can select this bit and you will be recognized as an authoritative bit. There is no special mechanism where it is decided. It's just based on if you are a flight controller, most likely you are an authoritative node. If you have multiple flight controllers, they can be multiple. I think there can be multiple. There should be allowance for multiple authoritative nodes as well, and they should operate in the same way. And I think all of them should reach at the same conclusion at the end of this, the resolution of the capabilities, as we are just doing an ampersand of the maximum node capabilities. All right. So this is the update on the node capabilities work. Now let's talk a little bit about what the future of Dronecam is like. This is like a general discussion. Again, a lot of these things are bound to change, but we can have a quick talk about what can we do to potentially improve Dronecam in the future. So for CanFT, of course, as I discussed, a lot of tests and analysis need to be done. We need to actually prepare. I think as it is, it would be more sensitive to issues compared to our CAN 2.0, which has been working fine in many applications. More and main reason is that we haven't reached those lands. But with CanFT, we will be reaching those lands, and I think it would be more and more appropriate that we actually create recommended setups for users to follow, so that the ecosystem is developed in a better fashion, and people make less mistakes while using CanFT. So this is going to be really, really important, in my opinion, for ensuring CanFT adoption. Next point is going to be extensible messaging. We need to allow ability to extend the message sets. Like we want to add, as I said, there's been just this vast number of messages created just for single type of information to be transmitted. We need to reduce that, right? So to do that, we can extend already existing message sets, like good message sets, not we probably won't take over a message set which has a lot of redundant informations like your covariances and whatnot, like in many sensor nodes, and that is quite useless information, in my opinion. Nobody uses that, but it is just there for some reason. So we can replace those things with a better message sets, and we can create a nice message level, set level, and update all those messages and add and extend those messages as needed, so that we reach a proper usefulness of these of the messages. So TAO, the tail area optimization, has already been made optional because of the work of CanFT, and this means that it can be quite easily achievable. On CanFT, you won't even require a capability spread to be set for this. Basically, CanFT will out of the box have to support this, as it doesn't have PO inbuilt anyways. So it will just have this ability to do it without much issue at all. Ethernet is a very nice avenue to look at expanding this particular protocol. I would say this is quite into the future kind of thing. Right now, we want to focus on CAN-FT. There has already been a lot of development in the Ethernet layer. We have, myself and Tom Pittinger has been working on, bringing Ethernet into the ArduPilot fold, and there have been some quite good success. And I think we had a website running from ArduPilot on the Cube, on the H7, not the Cube, but CubeRad that will be coming in the future. So basically, ArduPilot was capable of, you have this web page, or transmit your UDP stream or TCP stream, and all of that done inside the Lua script environment. So it makes it quite easy to do the configuration and all that. Hopefully next year, Tom or I will be able to present on that and see where it has reached. But I do see the promise of that layer as a transport for DroneCam messages. But right now, I think even the Ethernet itself is not that capable of a layer to transmit the DroneCam message. Like the CAN level of robustness is not achievable on Ethernet. There is a protocol called 10BASE-T1S, which basically has this, we were talking about that conflict avoidance bit in Canvas, and that has been introduced now into the Ethernet layer as well in the form of 10BASE-T1S, which looks quite promising. It's quite a new protocol. I think it was only introduced 1 or 2 years ago, and I think just now we have started seeing some chips coming out with this capability. But with the ongoing chip shortage, I'm not sure if it is going to even pick up until 1 or 2 years from now on. So looks promising. I think it's worth looking into, and we can look into it as we move. But for now, I think CAN-FT will surely suit all our needs, and we can use it to the fullest, and then move to this next version of protocol if we find it useful. What is one of the important thing that I think we want to do is just replace the libuav CAN, because it's just too complex and heavy, and it is already being quite tight on we are running out of space even for the 2 megabyte boards right now. It is just too heavy. I think it consumes up to 200, 300 kilobytes of space, which is just too huge for what it does. And I think we need to reduce that. We need to find a better, efficient way of doing things in the C++ domain, the application level features that libuav CAN introduces. We've already pulled out a lot of the features like dynamic node allocation and the interface connections from the libuav CAN itself. So I don't think it would be a huge leap to be able to move to a with libcanard as a core, a C++ library, which gives you the application level features that we need, like DNA node capabilities, time synchronization, your node status publishing, and whatnot. So this is something that I think is quite important and will be needed to done, I would say, in the short term rather than the long term. So yeah, I think that's all from my side. This has been quite a pleasure discussing with you all about DroneCam, and I think I'll accept some questions, if any, or if you want to have some discussions on certain topic. I'm open for that.
Fantastic. Thanks, Sid. So I totally agree on getting rid of libuav CAN. It's just monstrously large and inefficient and horrible to debug. So I think that's one of the things that we should think about aiming for maybe for 4.3 or 4.4 time frame. So 6 months to a year time frame to replace that. And it shouldn't be that big a job, because we're not actually
using that much.
we're just using it as a way oversized transport layer and marshalling layer, and it should be relatively simple, I think, and that'll save us a lot of flash space, making more room for things like Ethernet, which would be really worthwhile.
Right.
So I think things are looking very bright for DroneCam in ArduPilot, and I was intrigued by the changes to node capabilities. I didn't see them on the PR, so looking forward to discussing those in more detail.
I just, as I said, like this is a structure as I am doing
that's
it.
fine. No,
but it's going to change. It's the under development, kind of thing we can discuss.
Yep.
Even I am not quite clear on where it is going to head. I think I have general overview, but as the implementation goes, I think things are going to change more and more. And as I bring it to you, I think after that, there's going to be a massive change as well. I'm sure there's going to be a lot of requests from you on that.
We'll also get others. I think, like Daniel Agar involved and 32 bits from the other channel. So that'll be a really worthwhile discussion. But I think that's probably the next major milestone, getting that in, because that will enable us to start, rolling out people actual usage of CanFT, which would be great.
And actually start the work on the next stage of message extension and all those things as well. I think
a sane GPS message, much better ESC messages, etc. Once we've got the capabilities in, we can do that. So really worthwhile. All right, so Sid and I could chat all night about DroneCam. Does anyone else want to put things? Yep, Josh.
I've got a question for you, Sid. So there's been discussion going on replacing the battery messages on DroneCam, and one of those is how to send static data, send and receive. For battery information like manufacturer, serial name, all the other, like 96 bytes, we only want to send that one time. So how can we do that just one time or upon request?
So that is something called service request message set that will be required to use. I think we can do something like battery.cat, information as a service message. If you can just have this as I gave an example of get node capabilities message, right? You can request another node to send their node capabilities message. So basically, a drone lab, our AP where we can battery or driver can have this capability to ask or request, the battery data from this particular node, right? So they are aware of, which node it is. So all they need to do is just request that particular information from that. So that will be only a once a boot kind of thing, something that the battery doesn't need to publish every time. So
remember the context of that. I wonder whether we should have a general purpose static data transport and not just for batteries. So I'm wondering whether it's like exposing the equivalent of our @sys file system from CAN nodes, and because we've already got a file transfer protocol.
I mean, we already do the get node info. So get node info contains a lot of information about the name of the part, and even there is vendor specific information.
But that's structured. That structure and the data you can encapsulate in that is set at compile time. What I'm talking about is like an @sys file transferring, say, a JSON file. So you can have information transferred from a CAN node that where the structure of the data doesn't need to be known by the other nodes at compile time.
Right. I see.
And for gimbal control, that sort of thing. So a way of, because I think the question came up, Josh, in the context of sort of a general transport, static data transport mechanism. And
maybe protocol, something like protocol buffer over CAN or something like that.
Yeah, or JSON's tempting as well because it's so easy to do in so many different.
JSON is one, but I think JSON can be quite heavy. But I think for protocol buffers also, we have so many libraries out there now, like or something like that,
But we can work out sort of linearization systems. But the idea of having the equivalent of an @sys type file system and to get from CAN nodes, and whether it be read-only or read-write, but that would allow ground stations, because the ground stations have access to the CAN network now. So a ground station could fetch that sort of information and display it, and then potentially edit it and send it back. It would be really an enhanced version of parameters for controlling. You could imagine a CAN gimbal, for example, with that type of capability.
I mean, even parameters can be used for that, because parameters in like in CAN world, parameters as a string are supported. So string parameters are supported in DroneCam. So you can technically use the parameter system itself rather than that is also one approach we can take.
Yeah.
Anyway, worth discussing.
Regarding the parameters that was brought up and that was discussed is how to standardize those across, PX4, ArduPilot, and whoever else. This becomes a little bit more difficult to ensure every manufacturer does this name.
Yeah, each vendor will tend to have their own parameters. I mean, if it uses APPRIF, it obviously uses a standard set that we have based on capability. And although I think we can trim back our parameters, I think because we inherit the parameters from our libraries, we've inherited a few too many parameters. So compasses, for example, we have the offsets there, which are just not useful. And I think we should probably do some work to trim back some of the parameters we expose from our libraries and APPRIF. We've already done that a bit, but I think we could do some more.
And I think if we bring down the parameters, and the real number of parameters will be actually quite low. I mean, even the compass ID and all those dev ID or all those stuff is probably not needed even. I mean, it's a constant
dev
setup.
ID is somewhat useful for knowing what type of compass it is when it's behind a generic CAN node.
It is. It is. I mean, it is for us, but not like it is for the ArduPilot to know maybe, or but not the common user in my opinion. I mean, this is just an extra information that they can't understand that we are displaying maybe. But it can be under some sort of like advanced tab rather than having it as a list of parameters showing up. Just a thought.
Okay.
Do you have any show and tell, Sid?
Oh yeah. Do you have a cube bread lying around the fridge?
I have a cube bread here. I could hold it up and there you go. I did show it the other day when we had the talk from Robert Moore on redundancy. It was relevant. And Philip said I could show it.
Yeah, so basically, so the cube bread will...
do you have yours yet, Sid? Because yours isn't in a case.
Yeah, mine is not in a case, I think.
I could remove mine from the case.
Yeah, so that might be sort of interesting. You won't get it back in if you do, unfortunately.
I know.
I do have one, but I think I'll have to find it and then make sure where it is. I'll have to dig through the pile. Anyways.
It'll probably end up in a museum someday.
Anyways, moving on. Sorry about that.
Lost it already.
No, I haven't lost it. It's just
can't trust software engineers.
I've got a broader CAN question, if I may ask. I've heard people saying that as we're moving towards using like more ESCs and servos on the CAN bus, we're going to struggle because the CAN protocol will limit in speed. Is there any basis to that, or is it just sort of noise?
I think there is some basis to it, but it is something that you need to try and find out for yourself, like do the calculation of how many actuators you are attaching and all that. But I think at least as we move to CAN-FT, that is certainly not going to be an issue, because you are going to have up to 8 megabits per second of data transmission capabilities, which is quite a lot of data. So maybe for CAN 2.0, 1 megabit per second, it can be limiting if you are running at high rate. I do not have that particular number in my head. But with CAN-FT, I really doubt that this is an issue. With a fixed,
I do have a bit of experience with this. I've been helping some of the partners deal with transitioning across like larger quad planes to all CAN.
Right.
And one of the things that you need to advise people to do is renumber their servo outputs. So traditionally, a quad plane comes up with aileron, elevator, throttle, rudder, motor 1, motor 2, motor 3, motor 4. That's the default layout with ArduPilot. But that is a terrible layout if it's CAN, if they're CAN ESCs, because the way the actuator message, the way the ESC message works is that it ends up taking 3 frames, 3 8-byte frames to send each of the CAN messages out to your ESCs to get those 4 ESCs. If instead you move the 4 motors to the front, so the first four servos are motor 1, motor 2, motor 3, motor 4, and then you go aileron, elevator, throttle, rudder, right? You approximately use about a third of your bus bandwidth that you would do with the default layout, because each of those, in fact, sorry, yes, right, about a third. So it goes down, it's now 1 frame, a single frame to send out to the 300 or 400 hertz ESCs instead of 3 frames. And you also get a lot, if you get any packet loss when you're doing it with the traditional layout, then you lose all 3, which means you lose that frame altogether. So you're much less susceptible to packet loss just by renumbering. So, and once we have the CAN FD, that sort of issue goes away. But there is this transition period where you do need to provide advice. Now, this is mostly noticeable when they're trying to do bus analysis and they're attaching a CAN analyzer, like DroneCam GUI tool over SLCAN, and they find that the bandwidth on that is a bit lower. And so because it's trying to go over a slower link, right? And it's hard to see what their ESCs are doing.
Not just lower link, even the GUI tool is running over Python script. It is just not able to handle that much of information coming in.
It's having trouble. So it's partly artificial from the analysis tools, and being a third of the bandwidth is really good for those analysis tools, which is quite important for your bus bring up. But reducing your bus bandwidth by 2/3 is also really worthwhile.
Yeah, and also if you are actually losing packets or not, it is worth checking that. And you have this @sys/can_stats. Basically, it will actually tell you if you are losing packets or not. You will see the number of dropped packets. So do ensure that you check that, not just use the GUI tool. GUI tool is a good visual aid.
We should probably expose that in a mission planner tab somewhere. Right. CAN status, because knowing to go and get that @sys CAN stats, it's a bit too obscure. And I think a little CAN health type thing. I think a CAN speed test would be really good too, similar to our motor test, where you could have like a speed test and deliberately blast the bus with maximum packet rate and see what packet rate it can actually achieve. Right.
It sort of exists in one form, like blasting the message what you are saying, like blasting the bus with the message. We have got this CAN tester thing.
But that's not exposed. We really need a thing in Mission Planner with a button, a bit like the motor test, and what it should do is slowly ramp up the message rate and to see what message rate you can achieve. And that would give you an idea as whether your terminators are any good. Right. It would give some idea of sort of the your cabling health and how fast can you actually push it. And so I think these types of user experience things would really help and give people a much better idea as to whether their CAN bus really has good integrity. And anyway, that's a few little things, but just reordering that on a quad plane, enormous difference.
Can't we have this, just what you explained, can't we have that as a default thing for CAN? Like, why can't this be done as a default system?
The servo ordering, at the moment, the servo ordering default is set. It's agnostic to what transport you're on. And we could rearrange it so that, the default is the other way around. The problem is existing aircraft, a lot of people those parameters aren't stored in FRAM because they're using the default. And if we change that default, that means suddenly their motors would start spinning, when they're sitting idle, right? Because they're treated as aileron at 1500, and as soon as they upgraded to new versions of firmware, their 4 motors would go to 50%, and on some vehicles that would be lethal, right? Well, not quite, but dangerous.
But for CAN, we can do that. For CAN bus, we can do that, right? Because CAN bus, like we treat servo and motors differently.
Yeah, we could potentially have a remapping. We could have like a remapping system. The other thing we could do is I have proposed an alternative message for ESCs that doesn't suffer from this problem, which in a single 8-byte frame will support 4 motors anywhere in the range of our table, right? And I proposed that some time ago as an upgrade to the ESC message. That's basically pending on this node capabilities. Once we've got node capabilities, we can start switching over to this new saner message, because this original ESC message is just silly. It's because it's oriented towards just quadcopters. And CAN adoption is getting to be really quite high among the larger quad planes, and it's rather inefficient there. So I'm looking forward to getting node capabilities in place and then getting this new ESC message in place, which completely gets rid of this problem.
Right. Yep. Sounds good.
So that was a longer answer than probably you were expecting, Matt.
No, that was great. Give me all the top tips. Thank you.
No worries. All right. Any more questions at all? Before we move on, we're going a little bit over time, but it was a great talk. Thanks, Sid.
One last one, since I'm doing battery stuff. So we were adding a message to move out all the battery cells out of the normal battery, like the main battery message. Is there just can we just easily turn off and on a message via a parameter in the node? And would that be okay? Like, say our smart battery, most people aren't going to care about the cell voltages, but maybe I do. And resistances.
That's up to the vendor of the smart battery firmware, which if it's AP Perif, that's great. We can do it. We could have like an options bit, to turn that off. We can't do that for vendors like CUAV make their own smart battery, for example, CAN-based DroneCam smart battery. We'd have to request them to do that. There isn't a generic mechanism in the DroneCam protocol to tell a node, please stop sending this message.
Okay. Cool.
That could potentially be added. We could have a please be quiet, message. And then we'd have to have support for it, but it's a possibility. Probably an option bit makes more sense.
I mean,
that's what was my thought.
If you want to reduce the handling of the message, you can add it to the filter. So CAN has this capability to filter the message out. So if you want to not, handle this particular message, you can have, but it will still consume the bus bandwidth. Yeah.
All right. So thank you very much, Sid. That was absolutely brilliant. And now our final speaker for the conference, before we move on to the sort of dev team discussions about, future directions, is Pete Hall. So Pete, tail sitters. There have been marvelous things going on in the world of tail sitters, so I hear. So looking forward to hearing all about it.
Yeah. So should we jump straight into it, or do people want a few minutes?
I think so. I think probably jump straight in. We've only had one talk. People should have had dinner and had toilet breaks and things. So anyone want to have a break or jump straight in? No, let's jump into it. Go for it.
Right.
Pete.
So hopefully you can see that now.
Yep, can see it fine.
Cool. Right. So a tail sitter update, as Tridge says, we've been doing quite a few things. So tail sitters are much improved in 4.2. So I will cover sort of some of the updates that we've been doing, and hopefully we'll get lots of people building lovely tail sitters. So first of all, what is a tail sitter? So I think that the key thing is not actually that it sits on its tail; it's that it hovers at a different attitude to that it uses in forward flight. And we do actually support tail sitters that do not tail sit, which is a bit of a weird thing. So this is an example of a the Convair Pogo, so a famous manned big tail sitter. So you can see it does sit on its tail, and then it transitions and flies like a normal plane. And these tail sitters were actually the first like proper VTOL aircraft. So tail sitters were there first. You don't see them very much anymore, which perhaps tells us something, but they were the first. So we support lots of different types in ArduPilot, and these are a collection of some of them. So we've got this sort of dual motor tail sitter, which at least in ArduPilot is the very sort of the when people say tail sitter, people often think of this sort of dual motor tail sitter. So we've got two motors that do the roll control, and then we've got big control surfaces for doing yaw and pitch. Of course, we do also support single motor. So this will be like a 3D aircraft. So you can prop hang. So ArduPilot can also prop hang with 3D aircraft again. You need massive control surfaces because the control surfaces are your only form of control here. So you've got roll, pitch, and yaw just from control surfaces on these aircraft. And we've got vectored tail sitters. So you don't need the massive control surfaces anymore because you generate your pitch and yaw forces by vectoring the motors. And of course, roll is still by differential thrust. And then we support these so-called copter tail sitters. So that's basically a copter with a wing. So we get roll, pitch, and yaw from differential thrust and differential torque, just like a copter would. And then we've got a wing in the middle. And in fact, you don't really need control surfaces. You probably should have control surfaces, as we'll discuss it a little bit later on, but you don't need them. And then this is another example of a so-called copter tail sitter, and this one does have control surfaces. And then this Swan K1 is actually quite a nice vehicle because I think it's the first sort of off-the-shelf tail sitter that we actually support. So you can just go and buy one and flash ArduPilot and you're done. So that's the sort of the types we support. There's lots of variations on these types, but these are the main few. So a little demo video of the various tail sitters to watch as we discuss what this talk's going to be. So that's a tail sitter there that didn't take off on its tail. So that's a thrust vectored tail sitter. These are all Henry's various vehicles. Off it goes there. So first of all, I'll cover some of the smaller little bitty changes that we've done. Then we'll have a look at the control surface gain scaling methods, the new minimum outflow parameters. It's one of these copter tail sitters there. Just popped up. Then we'll talk a little bit about control surfaceless tail sitters. There's quite a lot of interest in those, it seems. We'll cover transitions briefly and sort of have a look at some logs of transitions, and then we'll talk about the new weather vaning functionality for tail sitters. It's a thrust vector tail sitter, again, one that doesn't take off on its tail, and that's the Swan K1 there. So I think Henry's got one of every different sort of tail sitter in his box of toys. And I think that's the last variation. So these are the sort of smaller changes that have little fix-ups and things like that are not massive changes that you would notice, but sort of little itty-bitty stuff that got fixed in the background. So first of all, the big change if you're setting up a tail sitter on 4.2 is that we've now got this Q tail sit enable parameter. So importantly, if you don't care about tail sitters, right, it hides all the parameters, so you don't have to see all these tail sit parameters that you don't need. So that's useful. And we've also done the same for tilt rotors. So it means us tail sitter users don't have to see all the tilt rotor parameters. And it removes in 4.1, we had some like weird combinations, like you had to set Q frame class to tail sitter, or you could set Q flame class to something else, and then you had to set Q tail sit motor mix. So there was sort of weird combinations of these two parameters that enabled tail sitters or not. So the key thing here, if you've got QTailSit enable, you're a tail sitter, and you can use whatever frame class you like. So that's a sort of nice improvement. I think it makes it very clear if you're a tail sitter or not. We got the ability to set level in both reference frames. So if you do your set level in forward mode, it will set the roll and pitch trim, and then you can sit it on its tail and do the set level again, and it'll set pitch and yaw. So that's a nice little improvement to get your trim exactly right. We can now transition to and from inverted forward flight. So usually you would sort of pitch over forwards and shoot off upright. And if you've got your inverted flight switch set in forward flight, it will pitch over backwards and shoot off upside down. Now we've got a dedicated build for the Swan K1. So as I said earlier, you can just go and buy one of these. You go and flash the dedicated build, all the parameters are there, flash the build, go and fly. So that's super nice, and hopefully we'll see a bit more more sort of off-the-shelf tail sitters in the future. I think it's, as I said, I think that's the first one. It would be nice if we could get some more sort of ready-to-fly ArduPilot tail sitters would be great. And then we fixed. So this was a really weird EKF issue. So people were often seeing this yaw inconsistent warning on tail sitters, and it turned out there was a bug in the EKF, how it init, that when you were sat on your tail with this exact 90-degree pitch up, as far as the EKF was concerned, this exact 90-degree pitch up, the init went wrong. So Paul fixed that for us. It was quite a weird one. If you were just 5 degrees off from the vertical, it was fine, but exactly vertical, and we got this init issue. So everyone with tail sitters was getting this yaw inconsistent message. So that's been fixed. So you should be not see that anymore. So first of all, I'm going to cover the gain scaling method, and I'm going to explain how the new disk theory gain scaling works and how you can set it up. So this is primarily for like control surface tail sitters. So either dual motor or single motor tail sitters. If you've got enormous control surfaces, it's worth setting this up. If you've just got little control surfaces and you've got vectoring, or you're a copter tail sitter and you've got lots of control power from either the vectoring or being a copter, it won't make much difference. But for these sort of dual motor tail sitters where you need the massive control surfaces, this can make quite a nice improvement. As it says here, right? So we rely on the airflow from the props over the wing. Obviously, when you're hovering, there's no sort of natural airspeed on the vehicle, so your control is all coming from the outflow of the propeller blowing straight over the control surface here. So you don't see any pusher tail sitters because you rely on the airflow coming back off the propeller over the control surface. So this is a new option. So we've got several gain scaling methods, and in this, to set this disk loading method up, you need to set your gain scale max to 4, and set your disk loading parameter. So you've got to have them both set, and we'll discuss this disk loading in the next few slides. So there's been a lack of equations in this conference so far, I thought. So I'm trying to make up for lost time here. So a few equations, I'm afraid. So this is sort of the actuator disk theory, it's called, and it's derived from Bernoulli's equation. There's a link there if you want to go and see how it's derived. So it's just a control volume here, and you'll sort of intuitively understand this, right? If you hold your hand above a propeller, you don't really feel the air getting sucked in. But if you put your hand behind the propeller, you see there's this huge sort of tube of wind, tube of airflow. And you can definitely see this on copters. If you're hovering over grass, you can see very sort of a strong sort of tube of air, right? So this is sort of disk theory. And then this is the equation. So we've got thrust is air density, the area of your disk here, the exit velocity, which is the velocity at the end of our control volume here, minus the inflow velocity at the top here, and just divided by 2. So we've got these sort of 2 stream tubes here. So it's drawn as 2, right? In actuality, we just do 1, and you add up all your propellers as if they were 1. So if you had, 2 props, it would just be 1. Sort of it does the math once for a bigger propeller that was of equivalent area. So that's our stream tube there. So that's our equation derived from Bernoulli there. So then we rearrange that to give exit velocity. So the thing we want is this exit velocity, because that's the velocity that's acting on the control surface here. So if we can work out that velocity, we can scale the control surface so that the response is the same, no matter what the throttle level is and how fast we're going and stuff like that. So we rearrange to give that exit velocity here. So just rearrange the equation, and then obviously we don't actually know what thrust is. So but we do know what our current throttle is, and we do know what the hover throttle is. So we say that
I think Peter got muted.
I've lost audio from.
He's muted.
From Pete. He muted.
you hear me now?
Oh, there you go. Back again. Yeah, you muted all of a sudden, Pete.
Weird. Right. I don't know where I got to. So
too many equations. That's what did it.
Yeah.
You're on point
baffled.
3. Point 3.
Point 3. Okay. So we say, throttle is linear. We've got our thrust expo. So everyone's gone and set that properly. So we've got this linear throttle relationship, so that we say our thrust is equivalent to our throttle over hover throttle times the mass of the vehicle. So we know that at hover throttle, the thrust equals the mass of the vehicle, right? Otherwise, you'd be climbing up or descending. So we substitute that in for thrust here, and then that gives us our equation for outflow speed. And then we have this cunning realization. We've got a M here and an area here. So that's actually disk loading. So we've got mass over disk area. So that gives us our disk loading. So that is our new parameter, QTailset disk loading. So that accounts for both the vehicle mass and the size of your propellers. So as a first step, you can just go and set this, right? You know how heavy your vehicle is. You know the radius of your propellers, so you can just calculate this. And if you've got a bunch of propellers, you just add up the area of all of them and just set that. And obviously, you don't need to change this for if you add payload or whatever, like just set it up once and you're good to go. So then we have to normalize by hover throttle, right? So that in the hover case, you always have a gain of 1, so as that you can go and change all the parameters and it still remains the same for hover. And it also means that, if you turn on this gain, you get a gain of 1 in hover. We don't start off with some massive gain and you have to go and change all your PIDs. So in the hover case, we know that throttle over throttle hover is 1, and we have 0 inflow velocity in the hover. And then in the general case, we've got the inflow velocity is from an airspeed sensor if you have one, and if you don't have one, we use synthetic airspeed. So then this is our final scaling. This big long equation gives us the ratio of the exit velocity to hover. So then we have always a scaling of 1 in hover, so you can go and change these. You can go and change your disk loading and stuff, and it will always be 1 at hover. And that is true for all the scaling methods. So you can also just go and change to a different scaling method. The scaling will always be 1 at hover. So you don't have to change your gains if you change the scaling. It'll always be the same in hover. And then we constrain the scaling. So we've got a minimum and a maximum. So you don't get like a divide by 0 and your scaling shoots off to infinity and the control surfaces can't keep up and stuff. So you can go and set this if you need to, so it doesn't sort of saturate your control surface and shoot off to infinity. So that all seems very straightforward, right? But actually, actually you can see, you know, this stream tube actually doesn't cover 100% of our control surface, right? There's a bit on either side that is not covered, right? And maybe you've got a longer wing, and there's a bit more control surface that you don't cover. So you actually have to sort of fudge this discloding value that you went and calculated exactly. You actually have to sort of fudge it a bit to make up for the fact that not all of your control surface is actually in this exit velocity. So you want to change it such that you get sort of the average velocity. So if half the control surface is in this sort of stream tube, you just half the discloding, so that on average you get sort of the average airflow over that area. And then well, that still won't be perfect. You still need to sort of tune it in a bit. So the trick to doing that is just to cover a wide range of airspeeds and a wide range of throttles. So I tend to just pin the throttle to full, so you climb really fast and then you chop the throttle low. So that covers a range of airspeeds, while at high throttle, when you sort of accelerate upwards, you get a range of airspeeds, and then when you chop the throttle, you get a range of airspeeds at low again, and you just lower the discloding if you see oscillations at high throttle, and hopefully then you should be good to go. And the key thing here is that we account for the inflow speed here. So when you're moving fast, we scale down, which the other scaling methods didn't do. So it should mean that you can fly around with more airspeed, wider range of throttle without getting into oscillations. And because all the scalings are one at hover, right, the closer you stay to your hover condition, the less you'll notice. But if you like razzing about or flying in Q acro and going fast and stuff, you should see some really nice improvements with this methodology.
Pete, quick question. What are the units of the disloading? In other words, what are you going to use? What do you use for the units? And that was the first question.
So the units are sort of kilograms per meter squared, right? But I didn't put units on the parameter because you have to fudge it, right? You still have to tune it. If there were real units, it would imply that there was a right value for a vehicle. You would just calculate it. So you can't just calculate it, but the starting point would be that mass over area calculation, which would be kilograms per meter squared.
And the tuning by high throttle and low, is that in VTOL?
Yep. So this is all in VTOL. So this is only used in VTOL mode. I should have probably had that on the first line. Sorry. Yeah. So you're right, Randy. We could totally apply this to coax copters and stuff like that. So basically, anything with control surfaces that are sort of acted on via the propeller airflow. I mean, you could use it in forward flight in planes, of course, but in planes you'll find that the dominant effect is the forward airspeed of the vehicle, right? The plane, the relative airflow from the props is quite low because you've got this forward speed. But in our case, we've no forward speed, and we've got this huge effect from the props, and we also tend to have massive control surfaces, which you do need, but it means you have to get the scaling right.
So what if you're in semi-hybrid flight? In other words, you're in very, I think you touched on it, but very fast VTOL flight with horizontal translation.
Yep. So this should work for that. Should work.
Does it mix the partial airspeed? You know, if you're going 10 meters a second.
Yep. So we've got our airspeed is this term here. So we've got a plus V0 from airspeed. So it's a combination. So on the left here is the airspeed from the propeller, and then we've got the airspeed from the vehicle moving forward.
Okay, but it's still only VTOL. So if you're in a fixed wing mode in high alpha, it's relying just on the normal fixed wing speed scaling.
Exactly. Yeah. But of course you can set up your Q assist speed and stuff. So you could actually transfer to use this controller at low airspeed if you wanted to do sort of fancy high alpha stuff, if you needed to. So that is this sort of disk theory gain scaling, which does seem to show quite a nice improvement. But I would only bother setting up, right, if you're one of these tail sitters that relies on the control surfaces. So you've got enormous control surfaces. It's not worth it for copter tail sitters. It will work, but you probably won't see much benefit because you've only your control surfaces are sort of sized for forward flight. They're not big enough that it would make a massive difference in that case. Right, so then we've got our disk theory stuff. So actually, there's a little extension we can make to this disk theory calculation that we can sort of specify a minimum outflow speed. So we can say, I need at least this much airspeed over my control surfaces to maintain control. So then we increase the throttle such that you always have that much airspeed. So in 4.1, often people would set like a bit of a higher spin min so that their propeller would never sort of go slow enough that you lost this nice airspeed over your control surfaces. So that does work, although setting high spin min has other problems, like you mess up your expo and stuff like that. But using our new disk theory equations, it allows us to sort of benefit from having super low throttle. So if you've built up some airspeed, you can chop to a very low throttle. And if you're hovering, you have a sort of bit of a higher throttle limit. And it also means you can potentially descend a bit better because it is a limit like at the motors level. So people often have to set quite a high, quite a low descent rate on their tail sitters because you're trying to fly a plane backwards. So you have to set a really low descent rate, which works. But then if you get a gust of wind that pushes you up, the vehicle tries to then catch up with the descent rate, and it descends a bit too fast, and you're trying to fly a plane backwards. It doesn't work. So we can use our same equations to derive a throttle level that will maintain at least the airflow specified in the over the control surfaces. So the param is Q tail sit min VO. So tail sitter minimum outflow velocity. So we've got our same equation for thrust, but this time we rearrange for throttle here. So we've got, again, the same equation, rearrange for throttle. Exit velocity is set by min, the new parameter. And then in the climb case, we can use airspeed here from the airspeed sensor. This should be the descent case. Obviously, the airspeed sensor doesn't work if you're trying to descend, right? The airspeed sensor doesn't read negative airspeed. So if you're descending, if the airspeed is 0, we use the body frame X velocity. So sort of we sort of have to guess the airspeed since you can't measure backwards airspeed, and that gives us this sort of minimum throttle level. And then we apply that to the motor's back end. So you do have to be careful. If you set this too high, the minimum throttle will be above hover and it will just climb. So you can make your vehicle fly away if you set this too high. So sneak up on it carefully. And the other thing to watch out for is that it's limited by our throttle mix parameters. So you might need to set a higher throttle mix to allow the motors library to boost up the throttle. So these throttle mix parameters, there's a min for landing, I think. There's a maximum for like auto throttle modes, and there's a manual for manual throttle modes. So you might have to increase those a bit, which allows the motors library to bump up the throttle for more than it's being asked for. Again, you will need to tune this in. So a nice way to tune it is to just descend and stabilize, like lower the throttle stick as much as you can and stabilize, and then set this parameter such that you don't, like if you chop the throttle completely very low, right, it won't stabilize. So you just increase this parameter until you can descend. So you won't descend as fast, but you should also descend level. It should keep control whilst descending. And we just do that by bumping up the throttle to get this minimum outflow speed. So you do have to have set up the disk loading stuff. So you need to be using the disk loading gain scaling. You can see we've got our disk loading term in here again, a disk over m. So that covers that stuff. So then control surfaceless. We get lots of interest on the forum. People want to set up control surfaceless vehicle. I do think it's a bad idea. You'll find that as you gain airspeed, your prop effectiveness decreases. So your props make less and less thrust, and the aerodynamic forces increase, which basically means your vehicle has a speed limit. If you fly too fast, you lose control. So we do support it though, but control surfaces are very nice.
They're a lot of fun to fly, but yeah, that you can get some very interesting crashes.
Yeah. So there's a magic QTail sit enable equals 2. So that's the sort of thing you need to set if you haven't got any control surfaces. So this enables active stabilization in forward flight from the motors, and it also forces sort of air mode is what we'd call it if it was a VTOL mode. So it forces air mode. So that means if you go to 0 throttle, stabilization remains active. So you need stabilization all the time to keep your attitude control. So it forces this air mode in forward flight. Otherwise you find like when you try and so you're doing an RTL or something and it tries to descend, it'll go to 0 throttle and lose attitude control. So we force on this air mode that sort of keeps the stabilization always active, and it does work very well. You can fly around at high alpha and do all sorts of things that normal planes couldn't do. You just have to be a bit careful not to go too fast and lose control. And again, that's the Swan K1, which we talked about earlier.
I was wondering, do those wings actually do anything, or is it really just a quadcopter that can fly sideways?
So
they do something, right?
Yeah. So So the wings provide the lift, but you still need to use the motors for stabilization. So you can't glide, for example. So one of the big advantages of a quad plane, right, is that you've got like redundant. You can glide or you can hover. You can't glide anymore in these. If you lose motor power, you're going to crash.
Easy to build though, I guess, as well. You don't have to worry about all the servos and things.
Yeah, it is.
It's pretty cool. Looks
yeah,
good.
you could actually support this in copter as well. It's one of the sort of vehicles that could be either, and we added it as a plane, but it could easily be a copter if you wanted to, because there are little racing quads where people have got add-on wings, to make the racing quads fly faster and more efficiently. And so there's this sort of, crossover point between copters and planes, where this could have been done as a copter, in which case we would have had to have better support for flying sideways. And because it flies nose down and nose up, and it very much flies like a plane for most of its time. It tends to take off for a few seconds and then it's flying on the wing most of its flight. So you'd have to support that in copter somehow. But
the big problem with supporting these things in copter is the thrust vector is not defined by the direction of the motors, which is what all of the position control and navigation assumes. The thrust vector gets, moves from being defined by the motors to being defined by the wings. And we have no support or accounting for that at this stage.
Yep. Whereas anyway, but it does do very smooth transitions. It flies really nicely, actually. Once we got it sort of, dialed in. Many thanks to Henry for his help with testing on his one, and I've got one as well. And it does fly very nicely and reasonably good endurance, that sort of thing. It's a nice aircraft.
Yep, just don't go too fast.
The big problem with these aircraft. Yeah, the big problem with these aircraft is they fly really nicely until your first little crash and the wings get slightly distorted. In which case, after that point, as soon as the wings start actually,
this one's surprisingly well designed. I've had several looked like quite hard crashes. I picked it up and flew it again straight away. This particular one, the Swan K1, they've done a very good job of that. And I've come down quite hard a few times when I was working on the development of this, and it picked it up and flew again. And it's really surprisingly robust aircraft.
It is indeed.
Do they have?
I've dropped it from 30 feet.
Do they have yaw tilt on the motors?
I'm sorry, what was that?
Do they have some yaw tilt on the motors?
Lots.
So the motors aren't all in the same axis?
You can see it in the picture there. So that's 10 degrees. They've got 10 degrees in 2 axes. So I don't know what that adds up to for total angle, but 10 degrees pitched towards the middle of the aircraft and 10 degrees. Yeah, it's a massive amount. Or you can't, otherwise you couldn't roll it properly.
Yeah.
In fixed wing. And
exactly. And that's the big mistake that most of these aircraft do, is they just have a normal quad rotor the yaw authority, the multi-rotor yaw authority just isn't enough to overcome any imperfection in the.
You need a huge D gain on the yaw axis, the VTOL yaw axis, for this to actually fly really well. And because it needs massive roll authority in fixed wing flight to overcome the wings to actually, to get good roll control and good navigation. Yeah.
Well, that's what was being discussed with Andy's talk with yaw. Once you get to a certain, if you've got any thrust vectoring in yaw, that's where D gain comes back into the equation. And with these small multi-rotors, there's because there's a bit of D gain advantage as well. But any thrust vectoring for yaw enhancement, then you start adding D gain back in.
Yeah. I've found on the quad planes that have got any degree of tilt on the rotors, you definitely want some D gain. All right, sorry for hijacking your talk. Keep going, Pete.
Right, so we also support control surfaces and motors, right? You don't have to jump to this control surfaceless aircraft. So this is Henry's box kite. So we saw this flying in his little demo video at the beginning. So in this case, you actually end up with sort of 2 ways of controlling the same thing. So we can yaw with differential torque on the motors, or you could use your elevons, and we could pitch by differential thrust, or you can use your elevons. So we actually have just introduced some new parameters for this, so you can actually scale up how much the control surfaces move relative to the motors. So particularly in yaw, you might find that the motors are working really hard to yaw the vehicle with differential torque, and your control surfaces are not really moving at all. So to sort of fix that, you might want to half your gain, so the motors work half as hard, and then you would set your scaling P here to 2. So it's sort of, you need to so the motors always have the same response. So to make the motors respond less, you reduce your gains, and then you make your control surfaces respond more by increasing these P gains. And it's just just one number, and it's a bit weird on these vehicles where you start to have multiple actuators for each axis. There's sort of 2 methods to actuate the same thing, and you have to weigh up sort of how hard you want to try with each actuator. And this is the sort of thing you could spend ages messing with this stuff. But in general, you want to sort of make best use of your control surfaces, particularly in where your motors are really have a hard time yawing the vehicle. You want to make the most of your control surfaces. And then you can use Q-assist speed, so we can actually stop using the motors for active stabilization once you have the control surfaces. So you could set Q-assist speed, for example, to automatically change from active motor control to sort of all motors the same throttle and use the control surfaces. We also have an option called, it's in Q options, motors only Q-assist. So that means that the motors still stabilize, but we use the plane controller for the control surfaces, and we use the I term from plane and zero the copter plane term. So what in practice, what this sort of means is that you have the motors for stabilization, and then the control surfaces are used sort of like trim tabs. That actually works really nicely. You have sort of really fast response from the motors, but they never like wind up really hard trying to achieve some offset, and it just uses the control surfaces to fight that sort of like constant offset. So that can work quite well in vehicles that sort of have control surfaces, but the control surfaces are not quite enough for, so on vehicles like this, where it's probably not aerodynamically stable necessarily, so the control surfaces are not quite enough to keep it stable in forward flight, but you don't want to be using the motors as much when you have got some control surfaces. So you can set this motors only Q-assist option, and then you can set this Q-tail set motor mix to decide which motors stay on in forward flight. So in this example, you'd need all the motors on in forward flight. But if you had, say, a plus copter with 2 along the wings and a top and bottom, you might say, oh, well, I'm just going to keep my wing ones on and switch off the top 2 in forward flight. So there's a lot of options there. And of course, we do support, for any quad planes, we support custom motor mixers from scripting. So we've seen a few people say you would have like 8 motors along a sort of biplane like this, and things like that. So custom mixers, because you're sort of, because you're mounting the motors on the wings, you end up with a non-traditional copter motor layout. So you can use scripting to set that up. Not just tail setters, you can works on copter and normal quad planes as well. But tail setters is quite a common use of that. So this is a little look at transitions. So there's been loads of improvements to transitions, too many to mention. So we've got lots of new parameters in transition, and the key thing to come and look at is the pitch angle, basically. So you can see this is a transition into forward flight, so we're in the hover, and then the thing you'll immediately notice is this sort of jump. There's this big jump, so that's a 90-degree change between the reference frame of the controller. So we just do a sort of sharp step change, a handover from VTOL to forward. So that's what this jump is. So the attitude control view always reports the attitude control being used by the controller that is in charge. So the VTOL controller is in charge, so we're nosing down in VTOL, and then we continue nosing down in fixed wing. So you can see we jump from -45 to +45. So that's the 90-degree change in attitude that the tail setter sees. So in this case, that's happening at 45 degrees. You can do it earlier or later. So that's Q tail set angle. So you might quite commonly set this a bit larger. So you stay in that VTOL controller where you have super nice attitude control a bit longer. So as you start using the forward flight controller later when you've built up a little bit more airspeed. So you might not have got quite enough airspeed to start using the control surfaces only once you've got to 45 degrees. So you can change that. And we also have this Q tail sit rat forward. So that's basically the slope of this line. So that's the pitch rate that it uses for the transition, and it's held in the both phases. So both the VTOL phase and the fixed wing phase hold this this rate until it gets to your desired pitch angle. So if you're sat there with pitching up, it'll slowly do this pitch rate until it gets to whatever you're asking for, whatever the pilot is asking. So if you were sat there with full pitch down, it would continue this lovely straight transition rate line until it got to whatever pitch down you were asking for. So it should be a much smoother transition. We always end up with a bit of a jump as it switches controllers. So that's just that the I terms are not quite right yet. As we suddenly say, "Oh, quick, you're a plane now." And the key thing to look for is you want this transition fixed wing done message. So if you don't see that, there are a few other ones you might get. That you can get transition timeout, you can get roll errors. So if you're seeing other messages, it means you need to futz with your transition a little bit. Excuse me. So before you futz with transitions, make sure you've got a good VTOL and fixed wing tune. So for the most part, we'll survive a sort of untidy transition, no problem. Just go up a bit high and go for it. So that'll get you into fixed wing, and you can go and tune up fixed wing. And then once you've got a nice tune in VTOL and fixed wing, you can revisit your transitions and get them working really well. So if you're seeing like transition timeouts, it means that the actual pitch is not keeping up with the desired pitch very well. So it's taking longer than it expected. So it works out how long it should take. It knows what angle change you've got to do, and it knows what rate you're supposed to be doing. So if it takes too long, it'll time out. So in that case, you either need to improve your tune so that it matches your desired pitch better, or try a lower rate here so it doesn't move so fast, or potentially move your tail setter angle so that it doesn't have to go so fast or go so far. So there's a few different things you can do to improve your transitions there. So this is going back the other way. So we've got all the same sort of the same stuff going the other way. So we've got an angle to VTOL. So again, you might find that the plane controller actually can't pitch up very hard. It's only got control surfaces to pitch up with. So it can't pitch up to 60 degrees or whatever. So you might need to set this a bit lower so that you do just a little bit of the pitch up with the plane controller, and then you do the rest of it in the VTOL controller, which has more authority typically. Again, we've got a parameter for the rate that you pitch up at. So you can see we're following that here. And then in this example, I must have had some forward pitch in. So you can see we follow that nice linear transition rate until we get to whatever the controller is asking for, and then it drops back to whatever loiter, in this case, whatever pitch loiter is asking for. So it doesn't it won't merrily carry on to 0 and then come back. It'll get to what it's asking for and then stop limiting. So again, we see this big jump. So that's the controller handover. And then often we will see this spike. So this spike is just a race condition in logging, because we sort of instantaneously change modes when the mode request to change mode comes through, but we don't update our transition state until the next quad plane update comes through. So these big spikes are quite common. It's not the controller doing the wrong thing. It's just a race condition in logging. So you don't need to panic if you see the big spike here. So it's accidentally logged the forward flight attitude control view. So we're down here at 90 because it's logged the wrong attitude view. It's in fact, it's logged the VTOL view for one time step. So don't panic if you see these spikes. And again, we're looking for this transition VTOL done. Again, you can get timeouts if the desired pitch is not keeping up with, or if the actual pitch is not keeping up. So you might have to lower your transition rate or something like that to get this nice, happy transition complete message. So as well, for the transition to VTOL flight, we have a new parameter tailsit throttle VTOL. So this gives the throttle value that we use for the transition. So this is when you first start the transition until you get to that controller handover. So it just goes to a constant throttle, and then when the controller handover is done, it will use whatever throttle depending on the mode you're asking for. So this is stabilized, so it's jumped to there because that must have been where the throttle was, or the throttle stick was. So the thing you want to do here is get it as low as possible. So you'll often see tail sitters come shooting in really fast. They do their transition and climb, 10 meters or something as they shoot up into the air. So to try and stop it doing that, you want as low a throttle as you can in this transition phase. So on things like the Swan K1, you can actually use 0, and it works great. You just have to set your throttle mix parameters such that it will bump the average throttle just enough to maintain attitude control. So you can use very low. And again, if you set up this new min outflow velocity parameter, you can set a very low throttle, and then you rely on this min outflow to bump up the throttle to the minimum required. So you sort of set this low and then rely on the throttle mix parameters and this min outflow to bump up the throttle just as much as you need. So like I wouldn't set it straight to 0, but you can set this very low and rely on these other parameters, and that should mean, so on the Swan K1, you can get almost level transitions with no altitude gain if you sort of slow down a bit in fixed wing flight. Obviously, if you come along at full speed in fixed wing, you're still going to gain a bunch of altitude. But if you sort of slow down a bit, you can use this throttle level to minimize altitude gain through the transition. So we've got a lovely video here. So we've also got, I'll just speed it up a bit. We've also got weather vaning. So this applies to all quad planes, of course, but we've got some new weather vaning parameters. So you can automatically weather vane, and we've got some options that are super nice for tail sitters. So we've got the nose into the wind option that everyone is familiar with from normal quad planes. And you can see that's what the vehicle is doing there. So it's yawing around such that it is coming back to nose into the wind. And then this will be either way, so you can go nose or tail into the wind. So tail into the wind seems a bit, it's a bit of a funny name, but it is nose into the wind upside down. So it's leaning backwards into the wind. So that might be an advantage, right? Because you have a maximum of 90 degrees to go either way to get to this, rather than you might have to go a full 180 to get to nose into the wind. So this nose or tail into the wind only really works for tail sitters, and it minimizes the amount of yawing that you would have to do to get to that sort of ideal condition. We also support side into the wind. So, excuse me, we also support side into the wind. So you'll find if you have side into the wind, it will like present the minimum like area. So here it's doing side into the wind. So you can see when we were nose into the wind, we were having to pitch at about 30 degrees to keep on station. But if we go side into the wind, we're only having to roll at about 10 degrees. So that makes it a little bit easier to hold station potentially, especially if it's windy and you're right up against your angle limits. So you can see how much of a easier time it's having. You will find, of course, like nose into the wind, you sort of benefit from the lift on the wing a little bit more, but then, so it might be more efficient in the hover, but then it makes it harder to descend because you've got this wing lift to work against, whereas side into the wind sort of takes that away. And then there's the option for only tail into the wind. So that's leaning in on your back. So you might want that for descending. It makes it a little bit like you won't have to lean so far into the wind because you'll make less lift upside down than you do the right way up. So there's sort of all these options, and we also have the ability to specify one that you might want to use for so there's enable, which is sort of the general case. Then you can override for takeoff and override for landing. So you might want to go side into the wind in your normal conditions. So you would set weather vaning enable to side into the wind. For takeoff, you might want to go nose into the wind. So as you sort of take off and then transition into the wind. And then for landing, you might want to go tail into the wind, so you have this advantage of not having to lean so far. And for landing as well, it sort of depends how your landing gear is set up, which one might be better. And of course, it's also useful for quad planes. Normal quad planes, you might want to have, because you can override to disable. So you might be taking off in a valley or something, and you lay your quad plane down on the ground in the direction you'd like it to transition in. So you can override the weather vaning to be disabled on takeoff, so it won't yaw around just after it's taken off and transition in an unexpected direction. It'll just transition in the direction you want, and then for the rest of the flight, it'll just weather vane as normal. So there's a lot of new capabilities, not only for tail sitters, but for all quad planes. Of course, I wouldn't recommend using any of them except nose into the wind on a normal quad plane. But we've got all these other options that should be really good for tail sitters. So that's basically the meat of the talk done. There's a few videos and stuff to watch. If anyone's got any questions, I'll go and have a look on the various chats as well. This is Marco's very cool Explorer, by the way. So it's actually all 3D printed. You can see he's flying around there.
Looking forward to that being widely available. The Marco's on the live stream, by the way. So hello, Marco. Noticed him commenting there. So fantastic. Thank you so much for all your effort that you've put in. You've put in a huge amount of effort into tail sitters over the past year. It's been absolutely brilliant. It's really taken us from, really mediocre support to really good support for tail sitters. It's been great. And also thank you to Marco for, constantly nagging us, and particularly Pete for responding to those nags, to, he's a very exacting user and really pushed us to get the tail sitter support so much better. It was really good having a user like that, pushing things. And Henry, of course, with his massive amount of testing he did with all sorts of different vehicles. Yeah, that's my one. That's my S1K1. Yep, got that in there. So really good.
Yeah, lots of demo videos at the end here. Yeah, it's great having lots of people testing.
That's flying, and there's really nicely now. Yeah, zero height gain on back transition.
There's still a bunch of little improvements we can make, like landing detection is one that we need to improve on tail sitters, and there's still a few little transition improvements we can make, but
yeah, there's still a little twitch. I saw it in your graph, actually, a little twitch as it goes between the two phases of the going from fixed wing to VTOL. There's a, as it hands over between those two controllers, there's it's not, if you were to shift the graph up by 90 degrees, it wouldn't quite be a straight line. There's a little squiggle in between.
Yeah, so let's go and find it.
There, so you see the green line
this
there.
Is the worst one.
Next one, that's the worst one, but I was thinking the next one, that way, even that one there.
Yeah.
See, that wouldn't, quite extrapolate from the green line above. It's like it pauses. And then, yeah. So it actually goes backwards a little bit by a few degrees. And so I think we could improve that a little bit. But these are minor things. And so it's streets ahead. And I really like, even on ordinary quad planes, I love having the weather vaning option to not weather vane on takeoff. That's really important. So I know I point the plane in the right direction. I know it's going to transition in that direction and not head into a tree when the wind's a crosswind. And I often take off quite close to trees because I like standing under the shade. So that's been a really useful option for me.
Peter, a quick question, can I?
Sure.
When you say that you're weather vaning, do you plan to have any kind of detection of the best weather the best facing the wind, so that it drifts the least? So doing a 360 rotation and see where does it drift more or less in this case?
So the weather veining is driven by, depending on what you have selected, it's driven by like roll or pitch angle. So it just yaws until it minimizes its roll. So it sort of, you have to be in position control mode, of course, so it doesn't like it if you fly about. It'll sort of weather vane.
Like on this video, it's weather vaning, but it's not controlled by the flight controller. It is manual, right?
Yeah, so this video is all manual flying about. This is actually a really old video, but
Yeah.
I like it because it proves that you don't have to be a flying wing. People seem to have linked flying wings and tail sitters. You can only do flying wing tail sitters. Normal plane tail sitters work great.
But when it does this, shouldn't be also optimal to have a routine that would detect the best position for being like this vertical?
Yeah, so it sort of does that. It rotates to minimize its sort of sideways effort, sort of automatically. It would be nice to like use our wind speed estimate so that it like automatically sort of straight away goes to a best guess, and then weather vanes are using this sort of roll method for the rest. Like once it's gone to its best guess as a starting point.
Okay, thanks. Nice work, by the way. And Marco too. Robustini is doing a great job with that 3D printed model.
Definitely.
So question for you.
Oh, yep.
So it's really cool to see the disk theory approach towards the high alpha as you transition. That's actually one of my first research project ever was high alpha tail prop hanging. One question is how fussy that getting that the amount of control surfaces in the prop wash versus not, how fussy that actually is. Sort of what we were doing, it was a sort of dual thing, getting stall detection, as well as via aerodynamic sensing. So we had lots and lots of pressure ports, but you don't really need that many. We had one or two just in the prop wash itself to get you that idea, and outside as well on the control surfaces, to get you an idea of how much actual pressure you had on the control surfaces. We did it for all of them because it was just a 3D aircraft, but just how fussy that is.
Yeah, I mean, it's not too bad. Like you and again, like the nearer hover you fly, the sort of more correct it is, right? The less it matters. So if you're just hovering, it doesn't make a huge difference. If you really razz about, it's actually not too bad if you end up with a bit of a lower gain than ideal when you're going fast. It sort of doesn't really matter that much. We don't want to be right on the edge all the time. So it does work well, and I think one of the nice advantages is like descending. It works well, sort of boosts up your gains nicely when descending. Again, you have to really razz about in like Q accurate or Q stabilized to really see what can happen, and you can just tune it up. So you sort of do these test flights, full throttle, get lots of airspeed, chop the throttle. So you want sort of high throttle, high airspeed, low throttle, high airspeed, low airspeed, high throttle, low airspeed, low throttle. So there's sort of 4 conditions that test the sort of extremes of the scaling. And you just try them all and play about with that disk loading parameter to get rid of any oscillations. As I say, it sort of has units, but I didn't give it proper units in the param description because you do need to sort of tune it in a bit.
It might be worth adding a bit of safety on that VO, so if you do set it a bit too high, you can bring the aircraft down.
So it is still constrained by your throttle mix. So if you've got low throttle mix, it should be okay. but it is possible, as you say, to make it just climb away if you set it too high.
All right. All right, if that's the end of the questions, then thank you, Pete, very much for the great talk and all the development effort over the last year on tail sitters and many, many other things. You've been an absolute star over the last year. It's been fantastic, the development you've been doing. So let's go to the final item in the conference for this year, and that's our development team discussion. And the way we did it last year was, I'll just bring up on my screen, just hang on a second while I get that up on my screen. I'll bring out last year. Now, James has traditionally run these, but James is here, but he was actually on his phone in a taxi until a couple of minutes ago. And he's just arrived in the hotel in Sydney and is currently trying to get a laptop set up there. So although he's on the call, he's here on his mobile for the next few minutes. So welcome, James. Let's see, we just need to go into the ArduPilot projects.
Yeah, I just put a link in the chat there as well. So I created a new project. Maybe I'll put a link to the old one as well.
Right, great. All right, so thank you, Randy. Well, in that case, given you're better organized than I am, I hereby nominate you as the screen sharer to run this session.
Oh, no, so, okay, hold on.
You're already ahead of me. But if we have a look at, maybe worth having a quick look at what we did for the roadmap 2021 and the way it worked. And so in the 2021, if you have a look at that link that Randy just put in the chat, which is the project/1, and what we did in previous years, we just kept updating that one project. So Randy's proposed this year we create a new project and leave the 2021 there and then create a new one. So we can see the sort of promises we made, and Randy and I had a look through this earlier today. And we reckon we got about a 50% hit rate on meeting the things that we planned to do for 2021. Of course, we got a lot of things done that weren't in this list, but quite a number of the items we did get done nicely. Some of them are still pending. So we had the text improvements that Paul talked about today. That was listed as we were hoping to get that in this year, but it's going to be obviously the next release, not for 4.2.
The like we say every year, it's the purpose of the list is not to like it's not like strictly enforced. The purpose is really just to share with other developers. It's just a method for sharing with other developers what you think you're going to work on. It's not like it's
it's aspirational.
Exactly, yeah, and it's that information sharing, and so. Not trying to force people to.
All right. Well, I'm going to start adding some items under plane.
Maybe I should unmute. So the new one, I created the same columns as last year, but obviously we can add new columns. We've got new vehicles this year, like the blimp, etc. So, but yeah, for now we've got a system level EKF, copter, heli, plane, rover, boat, docks, simulation.
Should we copy over anything? Like, should we just copy this and then delete what's done, or?
I don't know. I was thinking, that's why I had the two of them there. I mean, you might even be able to drag and drop them. I'm not sure, but I was thinking we would just recreate them, so copy and paste them or something. But I think.
Okay, you cannot drag and drop, it looks like.
No.
Or maybe just refresh the list, just delete what is done or what is not needed to be tracked and stuff like that. Just update this roadmap even.
We could update the existing one if you want, but I already created 2022. But, I mean, the way we're supposed to do it is as things were done, we're supposed to, drag them over here into the done column. But we didn't actually end up maintaining the list very much during the year. But I think we should decide what we're going to do, whether we're going to either use a new project, which Tridge is already.
I'm running ahead on the new one.
Yeah.
I think we
Yep.
just go with that.
I'm halfway there.
Rich has already done his bit.
Oh, I'm filling in 2 columns.
Like 30
So-
seconds ago, there was empty. Now there's like 20 items on here.
Well, I've put in 5.
Anyway, so
I guess at some point we should slip in Ethernet here.
yeah, definitely.
Oh,
So-
yeah. Well, do you want to add it in there or shall I add it in there, Tom?
Oh no, I'll do it. I'll do it.
You do
Actually,
it. Okay.
Sid and I will tag team.
Yep.
That one.
Everybody has the ability to add items here. I don't know. Sometimes GitHub, it's all part of GitHub, right? So GitHub has some funny permissions sometimes.
Hey Tom, Ethernet is so last year. You should be going to Wi-Fi.
Now, system level. Where are we going to put remote ID? System level? Or really, it's almost its own column.
Well, we can add one.
Or telemetry. If there's any other telemetry things we could think of.
We could put other hardware over here or something, maybe.
I might just put it under system level.
Remote ID, system level, sorry.
Yeah, I think system level probably, but it'll actually stretch across a whole lot of things, remote ID. So I'll just put it as remote ID support in there, but that's a really high priority one. I think I might start organizing regular meetings with Jeff about that.
I think we need another table for like AP perif probably.
Yeah.
And I think remote ID should go there, and I think remote ID should probably go there. I'm not sure, right?
Yeah, it isn't completely clear. I mean, we may end up with multiple solutions, some AP proof based, some not. But it's given that the new ESP32s do the Bluetooth level 5, I think it's called, that you mentioned earlier, Buzz. I'm intrigued about discussing that with Jeff. Is there any reason why an ESP32 AP proof node can't become a remote ID with Bluetooth? Because that would be
whether or not I wasn't paying a lot of attention in the remote ID talk whether or not we need a particular version of Bluetooth like 4 or 5. Did he mention that?
Might be worth going back and rewatching that talk, but I'd like to have a bit of a discussion with Jeff, maybe with you on the line as well, Buzz, about that and do.
4 is supported. 4, I think 4 is supported at least early on. The new spec might be 5 only, but 5 is definitely preferred due to its longer range.
Yeah, well, I've got in my hands a chip that does 4 and a chip that does 5. So
we picked the one that does 5, assuming they're available.
Yeah.
With remote ID, there's not only obviously the broadcast component of that, but also the ground control stations to receive it and the avoidance behaviors from the aircraft themselves. So there's quite a number of very different but interrelated components to that remote ID stuff.
Yeah, there's a lot to it.
That's why they wanted Bluetooth. Actually, one of the driving for that in particular is just because it's easy to have cell phones listen in on it. It's kind of out of the box.
Just need to install a government app that we're all going to trust.
Yeah, that was it. When Jeff was talking about that, who was in the audience on all those discussions, and it was the police and the fire and whatnot. And it was because they didn't want to buy an extra device to do this. They wanted to have pull up their own phone and be able to do it.
There you go. There's a small item with a big implications, dual H7 support. I think
wasn't there something to support the MET double precision of the H7s? And bring
we've already got that. We've actually incorporated double precision in 4.2.
For the H7 only, right?
No, F765 also, we do it. So we can do it on all boards that support double precision natively. So that's the F7, the higher end F7s and all the H7s. But the F765 supports it fine. So things like Pixhawk 4 does it by default in 4.2 release, Copter Plane Rover. And that's one of the things we needed to do to allow us to support very long distance operation. That wasn't the moving origin was the other big part of it, but the double precision was a worthwhile improvement. And really the big improvement of that was the navigation code for copter and the numerical stability of the EKF.
Yeah. The thing that you spoke in the beginning of the conference, the move to the new GBOs release.
Yep, I've got that listed. I've got that under system level 21.11 GBOS release.
Yeah, but it's not here on the new 2022.
Yes, it is. It's in under system level. It is the the fifth one down under system level.
You've added a bunch of them. I didn't refresh my screen.
Yep. No, I've been throwing them in there.
Yeah.
I was wondering about the cloud stuff. So we had that great presentation earlier with about the cloud.
I've just added a new column called everything else, cloud, web.
Okay, cool.
That's a good idea. Yep.
We should get rid of this. Maybe we don't need this simulation one. Maybe we're not planning to do much in that.
Well, I'm just adding one for simulation, the ignition stuff, all the boats. And so don't take my simulation column.
We need a one-hit wonder button for simulation.
Yeah, I'm adding that as the first item, ignition simulation, easier launch. So we need to make it really easy. At the moment, it's a bit of an ordeal to get ignition up and running, very worthwhile. It's a bit slow, especially with the wave. The wave model with the ocean is quite CPU intensive. So some work on perhaps less high fidelity waves, but a bit less CPU intensive waves would be nice.
What was the name of that application for the demonstration? Sorry, was it
Drone Engage?
Yeah, okay, great.
Drone Engage and
Andrew AV, ANDRUAV.
Andrew UAV, yeah. There's multiple pieces to it.
Drone Engage is kind of,
yeah.
Sorry.
Yeah, go on.
So Andrew UAV is the Android port of it, and when he decided he wanted to run on other things, he renamed the non-Android part to Drone Engage. Or Drone Engage.
And then it's up under cloud.ardupilot.org. We got permission from the funding committee to create a virtual machine for him, and that's what he's using. That's what's cloud.ardupilot.org.
And I've created him a Discord channel that is called Andrew UAV.
Okay, I was suggesting he could use AP Cloud, but
either.
I think
we've got a few too many channels. I think we should try and consolidate.
I think he could share AP Cloud. There's a lot of commonality there.
Yeah, even the companion computer one. Otherwise, we get all fragmented into little tiny groups, and then the conversation doesn't progress. I think we should.
Well, given they're completely different ecosystems, I thought they might start out separate. But we can change that if we need to.
Just need more grouping friends in Discord. Most Discord servers are grouped far further than ours. You should check them out with far more channels.
Really? More channels?
Oh yeah. Like go check out the tax server. Let's see, I'm in Zephyr. I have gaming ones, of course, with way more channels and way nicer.
You have 10,000 users. I mean, if you have 10,000 gamers or something, I can imagine you want to break them up into little groups of 10 or something. But
so, do we want to add DroneCam stuff into this as well, or we are keeping it separate?
We've sort of got that under system level at the moment.
I mean, stuff like new DroneCam C++ library and stuff like that, like application library. Where should that go? I mean, is that DroneCam?
Probably system level, because I don't have a wide enough screen for another column.
Not another column. I'm wondering if it should even go in the ArduPilot organization, or it's more like a DroneCam specific thing.
Oh, I see. But it's Yeah, we're going to be working on it. I mean, very likely. So
yeah,
I don't think it's unreasonable to have things there. I've already added the node capabilities. It's the first
yeah.
the item. It was the first one I added on the
I
system
also,
level.
yeah, I also
Yep.
add the message extension, but then I realized, yeah, okay, I guess we are using system level then.
Oh, there we are. We got. I was gonna say we need ship landing support in Copter, but Leonard's already put it in there.
Where should the barrow stuff go in?
That ECAF
And then-
estimation, maybe.
Then I'd also like to get in an actual full model for the US 1976 model.
I think ECAF estimation is the best place for that. Even though if it's not all in the ECAF, I think it's altitude estimation, isn't it? So in here.
Oh, by the way, Randy, I was just looking at the item from last year about the missing features from EKF2. We'd pretty much brought those features across from the copter perspective. I think from plane we have.
Cool. I don't think there's any missing pieces in for copper
Yeah.
anymore. I'll move over.
I think.
Yeah, one of the things we've got to decide is whether we stop it. Yes, we're gone.
I want to bring this up just because it kills me that we still don't have this, but the ability to store strings in the parameters. I don't know who can jump on that grenade, but
that would probably be me. One thing I did actually work on this morning that I will put it in system level so I can claim it for this next year. Proper storage of the default values of parameters, so you can download via the MAV FTP all the defaults. So that means that a default parameter list.
Yeah,
that's different from the defaults that are stored on our server from compile time. This includes the default stop harm effect and any set default, which will give the ability for ground stations to properly show what's different from default.
So an option to compact the storage. Well, I guess it's actually not all that important if we've got the feature that you're talking about. Come to think of it.
Yeah, maybe. So we'd have to garbage collection of storage is a possibility, but it was a fairly small patch I did this morning that it now enables us to accurately store. I haven't PR'd it yet. I only did it this morning. Accurately store the defaults, and that's the basic enabling feature we needed.
Do we have lure-based flight mode here?
Yeah.
Catridge, have you added the custom build server in here at all yet? I'm sort of trying to look for it, not seeing it. Adding stable and other branches.
Yes, that's a good point, and I'm guessing that goes under system level because just lacking anything else. So
web column if you wanted to. It's kind of a bit of
yeah, I guess there is a web column there. Docs Wiki one, you think?
Docs Wiki, or even further over the very, very right, if you have a super wide window, there's an everything else.
My browser wasn't wide enough. There is an everything else cloud. Okay, all right. So I will put it in there. And so that is custom build server branch support. And I have sort of scoped out how to do that, and I don't think it's a really big task. I think it's actually probably like a one weekend's job type thing.
Are you going to squeeze the ESP32 build into that one, or is it another separate task?
The ESP is much easier to add than the multi-branch that as we discussed earlier when Nick was on the call. It was it's not hard at all.
Also, another thing to evaluate maybe in the systems level is the Tibios sandboxes. Have you had a look, tried it, Rich?
I've looked at it, and I had quite a long discussion with Bob about those. I haven't yet found a compelling reason why we should use them. And they're going to, if we use it, for example, for Lua, it would make Lua much, much slower because of the way he did the calls, the system call interface. And I don't think we really want to make our system call interface in Lua that much slower. So for the moment, I don't think it's right for us, but we might change our mind in the future.
Does the sandbox have like this dual core kind of setup where two cores interact? I mean, is there an RPC, like remote process communication between the two cores and stuff like that implemented in GBS, if you're aware?
So the sandboxing is an RPC mechanism, but I haven't heard any discussions about the interaction between that and multi-core support. We basically haven't looked at multi-core yet using that F4. That's a matter of complexity versus advantage. I think the dual H7 is really compelling, basically replacing IRMCU with an H7. That's really compelling, and obviously you're doing the hardware already, and definitely worthwhile. The F4 support within the H757s, I've yet to see a really good advantage that brings us.
Yeah, one other thing I was thinking about, like giving an access to you have this Lua skipping thing, but what if someone actually wants to write a C++ application for a second core and fetch the information from the ArduPilot itself over through some mechanism? I think that would be quite interesting as well. So it can run as a separate program.
Yeah, it's getting the APIs and the linking and the build system, etc. It's quite complex. It adds a big level of complexity for the project, a maintenance complexity.
I'm hoping it. I'm hoping it to be quite simple, like as a separate project, which just ArduPilot just compiles as part of the code base, but it is maintained separate to ArduPilot itself, so that it doesn't add, the maintenance load on ArduPilot. But let's see. I mean, I haven't evaluated it properly. It's just some idea in my head for now.
Right. Okay.
Rich, something that comes from the experience with commercial systems, and it is the battery management, energy management system that we are just providing the basics. Shouldn't we perhaps start looking at that part of the systems in a different way, perhaps with some AP peripheral boards that would control this, and the partners could build it for the battery management systems? It's just a rough idea.
First thing I'd like to see is more availability of AP periph battery monitor CAN nodes, and to start getting those more widely used. So
it's a problem of chicken and egg, right?
I know, but just like AP periph was created to solve that chicken and egg problem. The hardware vendors didn't have the software bandwidth to create those. So we've solved chicken and egg problems before.
Question on that is, what type of ICs are you going to support? Or what level of depth are you going to get into that in terms of the hardware?
I don't know. I mean, talking about microcontrollers, big question is, are we going to do a GD32 support in the next year? There's been some partners really pushing for GD32 because they're available. You can buy them, and they're available with 3 megabytes of flash, which is also very attractive.
But from my commercial usage of platforms, I think it's perhaps where we lack the most for a wider adoption.
Battery management.
Yeah.
Yeah, no, it's something that Josh has done a bit of work, and we need to get you some of those smart batteries, Josh, that you said you needed to get some of those ones. I've got a couple sitting on my shelf. So if you can't get the ones
Eric's
from
sending me 2.
Oh, great. Okay.
From high tech. And then I'm gonna, if the funding committee approves it, get 3 from Rotori. So then I'll have 5 on the bus for I2C stuff, and I have 3 UAV can ones from Pomegranate.
Right. Okay, great.
So that's
a good selection.
Do a lot for that.
Well, hold on. I have all that hardware too. What was it that you're doing?
I just want to get a bunch of I2C ones on the bus because of that stupid SM bus delay that causes issues that Michael's worried about in my PR for the smart battery info stuff.
Okay.
Because it just needs something, because I'm not great at the threading, or I just need someone else to help me with like that one part of that one function to make it happy and him happy to know that it'll work.
Can you throw that PR into the system folder?
Sure.
Or maybe that's a perf thing.
It's right now. It's just like a Mavlink, and then eventually DroneCam thing. I mean,
but the intention is to be for AP to be well. Okay, yeah, because it is.
Tom and I can probably agree right now to fund those batteries, given that you've got 2 out of 3 of the funding committee on the call.
Yeah.
It works for me.
Thumbs up.
I'm trying to, so Paul apparently can't edit and add things at the moment. I'm trying to work out how we control who has write access into here.
I go to GitHub, I'm logged in, but then when I follow the link, I'm not logged in. So
okay, I think you need to work out how to get logged in again.
Okay, see what it's doing.
That's something in the try a different browser, maybe.
Yeah, maybe I'll try something.
Top right, you see the sign in.
If you want me to add something for you, happy to be a proxy, Paul.
Let me see. I'll see if I can try doing a sign in, see if that works.
All right.
So, Tridge, I'm not trying to volunteer you, but you did mention to me Zephyr once as something or other you wanted to think about.
Yeah, it's one that it'd be a great experiment to look at Zephyr as a possible port. If just because it supports such a wide range of microcontrollers, it would get us NXP support relatively easily. And it does seem to be a reasonably active, vibrant community. Yeah. So, but I have, no bandwidth to put into it at the moment.
I've been looking at Zephyr actually. I've been recently playing around for some other project. Yeah, I think it is a nice project with the, it has a different mechanism of setting up the pins and all. I think our hardware definition can quite nicely integrate with that. So yeah, it's certainly possible to add support for Zephyr. It should not be. I think it should be even less tricky than the GBOS one, because it just has so many drivers already implemented and so much easier to use. So yeah, I think it is quite possible to add support for it.
It's a matter of just, is it?
Yeah, working on it. Yeah.
Yeah. How urgent is it? Relative priority of that versus all the other things.
Well, if you're thinking about putting effort into, say, the GD32s, for example, maybe you might be better off avoiding the Chinese clones and going for the NXP chips.
I don't know if they're more available at the moment. The other thing is pricing. The vendors who are asking for GD32 tend to be very price sensitive.
And doesn't Zephyr get you more than just STM32 level processing power? Can you go then way up into mini
GBOS runs on on
massive
desktop
RAM
levels as well. But yes, Zephyr would open the gate to a wider range of processing power. Yeah.
Like
in front of my
that's sort of my interest.
This is a 800 megahertz Tinsy. It's an IMX 1062 from NXP, and it's cheap as chips. And 800 megahertz. That's pretty much all I need to say.
Yeah,
and
yeah,
12,
yeah.
12 UARTs or something.
That's right. Yeah, Tensy Zephyr with Tensy. That is actually a fairly compelling argument, Buzz. Yeah.
What about like a couple of areas that we're perhaps a little weaker in? One of them is camera gimbals, I think. And
yep,
I know that there's some gimbals that have that rely on Ethernet. Is that right? I feel like we have a blocker on adding support for some gimbals because they required Ethernet support. And I guess Tom P has put in an item here for AP network, full-ish network stack support. Is that Ethernet?
Yeah, I've Sid and I've been working on something. And I actually have a library of an AP network for doing stuff like that already.
And I guess Peter Hall also did some work on adding support for an Ethernet-based gimbal, right? Have we lost?
I think I did some work on the on-with camera support. So I think we can technically, yeah. So I think I did add some support for on-with camera control, and currently I think it is only running on Linux, basically Linux-based systems, because we don't have the networking layer yet for normal ArduPilot. But yeah, as Tom P just put it there, we are working on AP network for GPIOS based boards as well. So in the future, you can expect. Especially with the QBRED, we'll have Ethernet support, which will be able to control all these type of hardware. So yeah, expect to see things like this by next year. I think by next year you will see things like that popping up.
So am I right? Am I right in thinking that there are a lot of gimbals out there that require Ethernet? I mean, I have one here, but I don't.
Yeah, I mean, on-with is one of the most commonly used, high-end camera control system, and it uses this protocol called SOAP, which runs over IP protocol. So yeah, it is quite common. Yeah.
So I guess the only other option would be to add a little, Raspberry Pi or something like that, Raspberry Pi Zero or something, and have a little Mav link to on-with converter. I guess that would be another solution.
Yeah, I mean, so basically you can run sort of like an antenna tracker based Linux on your Raspberry Pi, and command it to do, because it is controlled by Mavlink. So you can technically just run antenna tracker right now on the Linux, which can accept the Mavlink commands to control the antenna tracker, and you will basically have the solution you're looking for right now.
Well,
because I think we support on-with.
I think that that Randy is missing a thing. The thing that we're doing with the AP network type stuff means that we would not need the Raspberry Pi.
Yeah. But Randy is saying for now, is there a solution? So I'm telling, there is. If you use the current on-with implementation, which runs on Linux as an antenna tracker, you can technically control that on-with camera using the Mavlink setup. So you run the antenna tracker application on the Raspberry Pi, which is connected to the camera through Ethernet and to the ArduPilot via a serial port, and you can just send the commands to the antenna tracker to move that camera gimbal, and it will send the relevant and on-with command to rotate that camera.
Okay, and is that worth it? Obviously, that depends on how much my time is worth or whatever, whoever's the developer's worth. But how long is it going to be for the if we could do it all inside of ArduPilot on a,
I think it's
Ethernet, is Ethernet support still a year away, or what do you think?
Yeah, Ethernet support is in a year away, but what I just said is currently supported. You probably don't even need to write a single line of code for that. You can just set up. Yeah.
Okay.
Yeah, I think probably a video is needed to show that, but it is possible. Yeah.
I could say that it's. I think it's more about a hardware availability a year away to really deploy it.
That is right.
The software is further along. That I have it working on not a deployed thing. It's still kind of experimental, but it's on an AP for if implementation. But it could easily be on a vehicle. Hosting a web page with embedded files in it for so it's running a whole HTTPS or HTML web server multiple IP, UDP and TCP connections, streaming some JSON, some Navlink, a variety of different things over IP. So
for test hardware, there's also we support the Holybro 5X. It's got an Ethernet connector on it already on their standard board. And so that makes for an easy test platform. Plus the things like these little Nucleos have, like this Nucleo here has an Ethernet connector on the end of it.
Right? So I have that board and another board that I've been using. But so far, all I've needed it for was for periph devices. By the way, our aircraft has like a dozen periphs in it. We have like just a whole bunch of things that are all interchangeable and stuff. So we've been diving in hard with the periph things.
Tom, a quick question. If you have 12 peripherals, how do you sort out the issue of updating all of them? It's a one by one, or can it be
sorting out what thing? What?
Sort out the updating of firmware on those peripherals. Imagine that you have 12 peripherals, all CAN bus.
Yeah, well, so they're all, a lot of them are actually different hardware platforms. So yeah, usually they're, for the most part, pre-programmed, at least initially, before they go into the aircraft, so that we know how to identify them. But yeah, so I mean, once they're already in there, plus they're on different buses. So on our aircraft, we have one bus that's like the fuselage, and one bus that's the wing, so we can kind of identify which. But we have things. I shouldn't say a dozen periphs, but we have a dozen CAN devices.
The issue is when you have multiple peripherals on the vehicle. We don't have an easy way through ArduPilot to update the firmware of all of them. So you might have, imagine one battery with a firmware, and the next battery comes with a different firmware, and we behave differently, or a GPS.
Firmware update from microSD would be worthwhile for peripherals.
To answer your question, Luis, is for that is you can there's two things. You can update the firmware, no problem, by targeting each one and do the updates. But also there's a board serial num parameter that's in there. So if you actually set that to 1 through whatever 32,000, then it will actually identify that in the name. I appended it in the name, so when it says org.ArduPilot or whatever name it is, it'll actually have in parentheses the board number, so you can identify it just in your list of devices.
But I think everyone knows what I'm trying to say. So it is, we don't take care of the firmware that is available on peripherals. So you can plug in an old U-Blocks GPS with an old version, and we don't have a warning to the user or an easy way to update that firmware. So if we
I think this is more a GCS or the basically the configurator and thing, because I think this information is very difficult to encode in the ArduPilot itself. That's my thinking, I guess.
The CAN over Mavlink will make this easier, because it means the ground station, without going to a USB cable, etc., just over your radio link, you can get the firmware versions of all of your nodes into the ground station, and then you can actually update it from your ground station. That should make life a lot easier. But I do think we should be able to support updating firmware, both of the FMU and of your peripherals, from the microSD, which allows for easier bulk update. So you could say that all of these models of ESC should be running that firmware, and you just put that firmware on the microSD, and then it could then do a bulk update out to all of them where the FMU drives that. I think that would be quite nice.
Yeah.
Agreed.
Or I wonder if it can be part of like a firmware update package where the firmware first updates itself, and then there is additional like APP files that you also want to upload in some same update cycle, right? So first it flashes the firmware and then puts the file in the SD card, so that you have this whole thing, as a single click setup rather than going through the manual process of updating each and every hardware. So if you have a drone, yeah, basically with multiple peripherals, you have a single firmware file for that drone to do that all of that update. Yeah.
One thing to think about that I just saw Matt's massive number of airspeed changes, yay, is how to support angle of attack and side slip sensors, because we're getting requests from those from some of our partners and a few PRs here and there, both in terms of logging, estimation, control, all those things.
Oh, that reminds me of the air brake from side slip.
Oh, yes. Okay. That's actually that's a nice little one to add. I'll just put in that. Are you going to put that in, Tom, or shall I add it
Yes,
in?
I'm already tapping it in right now.
Right. Yeah. Yeah, that's a nice, easy one to do. Yeah, that could just be a gain, and you could do it as a negative gain for doing left rudder versus right rudder.
There was also something for air braking that we've kind of been talking about internally, but haven't really done much about, is air braking via windmilling on the prop. So if you actually have 1 or 2% of your throttle, it actually has a net negative drag.
Yes, so that's one I've thought for gliders, particularly bringing them down. Yeah, so air braking throttle percentage.
Yeah, so it needs a complicated
well, to do it really properly, you sort of need to know that what advance ratio and that sort of thing to really, but you could just have a throttle percentage that is used, during the landing approach, not once you're in touchdown. Once you're in the final bit, you want to probably turn off your motor to not break the prop on the ground. But during the approach, you want to have like a minimum one to increase drag.
Yeah, and a lot of it too is just to drop altitude without overspeeding.
Yeah, the combination of the side slip and the throttle percentage could actually make for much steeper, more accurate landings.
Yeah, on our previous version of the aircraft, we had proper air brakes where we had 3 flight surfaces on it. So we had differential spoilers and all that, and we would just drop out of the sky if we wanted to. It was really nice.
But a fuselage is a pretty good air brake.
Yeah.
A couple items I'm wondering about. Was it Leonard who brought up the point earlier about the Lewis scripting flight modes? Did we add that somewhere? I couldn't quite see it.
It's sort of in like AP vehicle level, right? It's
not exactly system, not exactly copter.
Yeah, I mean, probably one of the vehicles will take the plunge first and add proper support for it. But yes, I would very much like that.
Stick in copter for now. Also,
it'd be nice to be able to get rid of things like zigzag out to a Lewis script.
Yeah, it's going to be tricky. Zigzag is actually going to be a tricky one, but there's others that could go, perhaps.
Yeah,
I know zigzag is always the example that people bring up. It's had some tricky bits added to it since it was first added to the code.
That just makes it a good case to make sure that it's fully featured.
Yeah, I guess.
One big one, which is potentially, is very complicated, Leonard, is what do you think about supporting airspeed and S-curves, which I know has been battered around a bit.
That's actually, the hooks are already there. I have been thinking about that because Heli has some potential use of that. There's a number of different ways we can do that, from actually physically changing the forward speed just by do set speed, but the new pause mission functionality and also the train following functionality both enable you to slow down the forward speed as you need to in S-curves, basically at will on a slider, and that could be used to sort of scale between 0 and 100% speed to maintain a particular airspeed. So yeah.
Okay. Sounds really good. Cool.
Yeah, there's options there. And those hooks are sort of there and fully just ready to use. You know, it just may not be compatible with both that and terrain following or something. You know, there's, yeah.
Sure.
I guess the other area is object avoidance, and a couple come to mind. I know that Triju mentioned earlier today, Lewis script-based bendy ruler.
I've got that listed in the plane. Yeah, that's a really big item for the next major release.
And I guess in Copter, there's a couple of items that we've left on the table from Reshab, including 3D loiter, sorry, the 3D back away in loiter.
Also, a big topic that we didn't talk about, or that was a talk, was redundancy.
Ah, yes. There's the
we've got the dual H7 support.
Yeah,
and that's related to that. I mean, that's sort of the likely hardware platform that we will work towards supporting. But that once that works, that should support redundancy on all sorts of dual setups. But I think the one that people, if you've got a flight controller out there with, you know, built-in redundancy, that's going to be the one that people are going to choose. So I think concentrating on that one.
Well, yeah, but it's, I think there's software components and there's dual H7 is kind of a hardware component.
Yeah, there's a lot of software components needed. So we could list that separately, the redundancy. And in particular, we have to have it in CITL as well. SID's already paved the way for that with the AP preference CITL, which is 2 processors. But, you know, we need to support, dual ArduPilot in CITL. So you can just fire up with an option to sim vehicle that says, you know, I want 4-way redundancy or whatever.
Yeah, they would need to do things a little bit differently and perhaps rejig the way we do the simulated the CAN GPS stuff, and perhaps pass around the the world state when it comes to it rather than the GPS data.
We've got to work out the topology for Mavlink in that. You know, do we, you know, does it try to appear as a single system ID? Does it try to appear as an aggregate system ID plus a system ID for each of the redundant nodes, which I know Buzz has done before?
These redundant nodes. So these redundant nodes, will they talk on DroneCam, or what protocol are we thinking they will be talking about?
Well, both. We've got to work out how it works at the CAN level. We've also got to work out at the Mavlink level how it appears to the ground station. If you've got, you know, a triple redundant flight controller, does that appear as a single system, you know, in your little drop down on the ground station, or can you drill into separate ones?
I think the master broadcasts both on its own, and the canonical vehicle system ID, and the other two just broadcast on their own or send on their own.
Do we want to have a concept of master in the first place in redundant system?
We had a virtual ID that was handed around between whoever was in charge. So you had system ID 2, system ID 3, and system ID 1 was the virtual one.
I would have thought
that might be the way to go.
I would have thought said anything not in standby was considered the master.
Right.
But yeah, like the master, the master hardware or whatever is always using component ID 0 or something, and the other guys have their own little component IDs.
How did you go with the duplication of data? Because I just said that you'd send on your own ID and the master ID.
Yep.
But that's kind of wasteful of bandwidth. We don't have that much bandwidth on the radios.
Yep. So we had 3 sets of HUDs, like 3 like horizons on the HUD, and you could split the Mavlink streams out, and you can set the stream rates separately on them. So we had the master had a much higher stream rate, and the slaves didn't.
Right.
So that was convenient.
That's cool.
Gives you situational awareness about the overall state of the aircraft when you've got 3 or 4 or 5 horizons, and one of them diverges, but the rest don't.
I think also the DroneCam will need an update. I mean, I guess the DNA needs to be more distributed and centralized as well.
Yeah, there's a lot of work for it to get redundancy done right. I don't think we should necessarily aim to do it perfect first time. You know, getting some level of support for, you know, dual H7 is worthwhile.
Yeah, I mean,
because otherwise it'll just never happen.
Switch, right? If you just do it on a switch, that would be the first step, right? And that's
right.
a massive step forward.
Yeah. Yep.
A couple of points around the redundancies. Like, we already have the ability to run multiple instances of SITL and sort of have the framework to be able to kind of talk to a companion computer which sits on top, or some other system which sort of moves between different vehicles or different flight controllers. So that's already there. And then the other thing that we have to bear in mind is that I think one of the biggest interests in redundancy is actually because people want to use ArduPilot, which is a non-certified system in a certified aircraft, which means that the main reason for going for redundancy is to have to move away from common cause faults in the firmware. So, you know, there's only in terms of, we need to think of redundancy around how do we support like companion systems from being able to sit on top of ArduPilot, and then other systems to move between them, because that's one of the key interests of redundancy, as far as I'm aware.
Yeah, software diversity and running two different versions of ArduPilot would be something that we could, you know, test ourselves. You know, you might run two slightly different versions, but yeah, it's harder to know what to do about actually running full diversity, running a completely different flight stack on another node, and how we interact with it.
I can't imagine there's any standards around this. I think it's all
DroneCam. I mean, DroneCam is the standard for potentially that can be used here. Hoping that people who are developing other nodes to be used as a flight control, as a parent flight controller, use the DroneCam protocol. That would be the protocol to use to communicate over, I guess.
Yeah, in fact, actually, I was doing that at Intel. I had a design that was semi-functional. That was they were both the same version of ArduPilot, but one was running on a Linux embedded computer, and then another one on an STM, and they could fall back to each other, master-slave style. So that's,
yeah. The problem with master slave is that there's no way to decide the truth. The system I worked on was triple redundant, so we had to basically, they voted on, you know, which two agreed the most, and the third one was out.
Yeah.
Actually, so the one I was working on wasn't necessarily a master slave, but it was designed that Linux is kind of your primary, and you could always fall back. But basically, the idea was you could reboot your Linux computer and still be flying. Was the idea?
Yeah.
Or at least fly home or whatever.
I wonder if there's items in like the non-GPS area that we haven't included. So we talked about object avoidance. We talked about.
Yeah, I'd love to get the ANU VIO system integrated. That just depends on working with the ANU people on that.
Anything else? I put upward-facing optical flow is an item that I added. Just wondering if there's other non-GPS stuff.
I'm afraid that this list is so big that I kept throwing stuff on there that I'm not sure is actually a legitimate 2022 item.
Yeah.
Yeah.
As long as you're planning to do it.
Yeah, in fact, I put string params and then I removed it.
Yeah, it's not fair to like put stuff on Tridge or something like that.
Yeah, exactly. Yeah.
You're only supposed to put your own pledges on there, not like things you want Tridge to do for you.
You could put a year in there that you think to get it done by. 2030.
Yeah, exactly.
Well, Tom's wanted it since like 2015.
I think with Ethernet stuff, we will definitely need it.
Yeah, if only we could just, if I could just take a whole year off work and just like spend a year on implementing that, we'd be.
Well, that would be work, wouldn't it?
Yeah, well, it'd be. Yeah, that's true.
This concept of taking a year off work and then working on work, sort of, it's.
Yeah. Seems like it's a holiday for Tom if he's working on parameter system. A vacation. Yeah.
They're pretty
If
good
only you
listening.
knew.
Equivalent of busman's holiday, but ArduPilot devs. Yeah. This is pretty good. This is there's a long list under system. So I think particularly Sid and I are going to be busy this next year.
Yeah, I was going to suggest that we break
don't
out.
plan on any big events like, I don't know, getting married or anything like that, Sid, you know.
Yeah, I'm getting that.
No time.
This month itself. So yeah, that's over with. So we can continue later then. We'll have all the time we will have.
It may be worthwhile to bring DroneCam out to its own column.
Is there any interest in pushing forwards in the like developing the RC input to support multi-RC input, like starting that structural work that we'll need to get done?
I've actually done some of that already. I actually pushed in some changes. I don't know whether you saw it, emerged in some changes to improve that already, Leonard. It's not quite to the level that you described, but it's a lot better than at the point when we discussed it, you know, that call a few weeks back. I basically found a shortcut to achieve a fair chunk of what's needed, but there's more to be done. So for example, you are now, when it switches between the two, that you actually get a notification on the ground station that it switched between the two and which one it switched to. And it now switches fast without a fail-safe happening in between. And so it's already, you know, 70% of the way there to what we discussed.
Yeah, because a lot of this stuff, you know, it's not, you know, you try and do it all at once and it's just too big a thing to chew off.
Yeah,
that's what
I thought it was going to be a huge job, and I found a short circuit. And I'm also now flying regularly an aircraft with dual RC on it. And two different RC systems, one the RFD900X using S-bus output and a F port. So I've got both of them in a quad plane, and I can switch between them. So it means it's getting regular testing.
Yeah, I wanted to do the throttle time constant takeoff, you know, for a couple of years now, but it's been one of those things where I've got a list of things I have to get out of the way before I'm able to actually tackle that problem. And I think I've actually got everything cleared to a point where I can actually attack that problem now. So fingers crossed. But yeah, so I'm not sure if we need to put everything in there or if there's just little steps along the way that we could isolate to try and get done.
Looking at this list, I reckon you got off pretty light for this coming up year, Leonard.
I know the copters looking like
it's done. Copters are done. You know, their history.
Well, we've got through it. It's getting pretty damn polished now. You know, getting guided mode sorted out, and you know, like all of the big stuff's been done. If we can get this takeoff stuff,
vectored motors.
What's that?
Vectored motors, thrust that doesn't go up.
Yeah, but that's a different frame altogether. That
could come in scope in copter.
Oh yeah, it could. My point is that's a frame problem, not a copter framework. Like that's an individual frame class thing. There are a few, you know, there's potentially some more flexibility in vector, like in the way we handled, you know, we talked about the VTOL thrust vector problem with the wing. Yes. I've deliberately added handling in there that would allow different frames to implement that thrust vector differently, but we haven't actually separated that out and made it usable, for example. But
I'd like to have support for asymmetric acceleration, velocity, and jerk limits, so we can have a different accel limit. Remember, like that discussion we had on the quad plane, you know, ship landing. I'd like to have a higher limit on pitch up, you know, in a quad plane than I have in roll right, you know, acceleration, that sort of thing. So some asymmetry, because currently that's done as a uniform limit that's omnidirectional. So, you know, I've had to hack that in at the moment, but there's some downsides to the hacking it in that aren't great. So that's something that I might come back and discuss with you a bit more when you've, you know, got a bit of free time.
Well, the things like the S-curve, the S-curve's navigation with that, it's sort of along the same sorts of lines with the lateral thrust for corner accelerations, and accelerating and braking, acceleration limits being different and things like that. A lot of that stuff I don't do simply because the number of extra parameters that would be required to support that. And until I've got something that's a clear example of needing it, it's hard to even envisage when I would need it. So
I think I can explain a pretty clear case for quad plane.
Yeah, with the quad plane stuff, that is a clear case, and we've talked about that. So we can.
You're also going to have to help Michelle get S curves into Blimp.
Yeah, I saw that too. That's a good one.
Yeah. I did see
that.
That
mean plane's the only holdout.
Yeah.
Yeah.
Well, it's got to be done appropriately, right? I'm not like, you know, S curves isn't just the generic solution to everything.
Oh,
it's not.
I thought it was.
Yeah, just
makes you breakfast.
Put it in, and then ask Leonard to tell me why.
That's right. S curves is a way of transferring all your problems down to Adelaide.
Yeah. Oh, shuck asymmetric. Asymmetric limits, asymmetric body frame limits in as a POS controller consideration. I can't promise anything because I don't have a solution for it, but it's something to think about.
Yep. All right. I think we're getting close to being done.
Yeah, looks good. I wonder if there's anybody missing here from this meeting who probably are a couple of people.
Submarine missing. What? We don't have anything on sub.
Yeah,
that's true. S curves.
Already got him. Already got him.
Done it. What? Look at Leonard's problem.
No, it actually does technically have S curves. It's just that it doesn't make use of them. So it stops at every waypoint. So it never gets the sexy cornering because it's always with the
okay.
So.
Well, but this is sub.
Were you talking about Paul sub then? Yes.
Question for Pete. Pete Hall.
Shoot.
Landing detection, tail sitters.
Yep.
Improvements.
Probably.
Especially for non-vectored.
Yep.
Pete, that was very committed.
Well, I mean, you know me, I bat around and work on all sorts of random stuff as the fancy takes me. We'll probably do it this year.
I like that. As the fancy takes me.
Yeah, you gotta have fun.
You know, Paul had mentioned an interest in text, and I was looking at my issues list, and like 4 years ago or something, I have an issue. No, 6 years ago, I have an issue that I put auto tune for text.
Yes, I would very much like auto tune for text. So I'll put that under plane. I have actually had a bit of a discussion with Paul about how we might do that, how we might do at least part of it.
You could put Tom's name on it, get him to do it.
Yeah, I was gonna say I can't do that.
Another vacation.
I think
another vacation.
I think what we can do is, at least for some of the parameters, we can tell that the parameter is definitely too big or definitely too small, and a bit like we do servo auto trim, drift it towards the right value in normal flight. So I'd like it to be, rather than an auto tune mode, I'd love it to be some way, a bit like servo auto trim, where it just, as you fly, just gets better and better.
For the record, I wasn't volunteering, but I was trying to throw Paul under the bus on that one.
I've wanted that for ages. Yeah. All good.
You never commented on the issue from 2016.
Oh, okay. Well. Yeah.
Yeah, and a big one for plane is the stall detection recovery stuff. I tossed in my PRs in there, but they need to get reworked a little bit probably. And but
and I've got
been using it for a
version
while,
of that
so
as well. Yeah, I've been discussing it a bit with Josh lately as well. All good. I'm getting pretty tired, and Henry, I'm amazed that you're still awake. Middle of the night. That is dedication. So
no,
you know,
it's early morning. I just got up at 5 a.m. for Pete's talk. That's all.
Yep.
Right. Okay.
Welcome to the US.
Okay. You weren't up all night then. Right.
Might just be self-preservation too. Make sure nobody lines you up to something when you're asleep.
I actually was looking at that.
We can add stuff later.
I had my alarm set for Sid's talk, and then I was like, oh, I don't think I can do it. So, but I woke up for this one.
Yeah. Oh, good. Well, okay. So thank you all.
What was that, Sid?
And we'll have to work out how the conference format's going to work next year, because you know how many of the people are coming to Canberra versus how many are done remotely.
Just recording.
Yeah.
All right.
These are going to be goals next year? I think it's goals.
Well, the pizza place, I spoke to them last week. The orders set. We've got a date. So yeah, the ordered the pizza in 2019.
What you're saying is, if nobody actually comes physically, then we get more pizza.
We get to eat a lot of pizza. Yes, an awful lot of pizza. We will have to invite many friends over.
If your definition of cold is snowing, it's probably not going to be that cold.
Yeah, that's fresh made pizza. All good. All right. Well, thank you to all the presenters at this conference. It was a great conference this year. Really enjoyed it. There was some really good presentations, and thank you for all the input on this last session of what we're going to try and get done over the next year. Very much aspirational. I'm sure, like in previous years, we won't get it all done, but hopefully we'll take a good stab at it. We've got Andy to add in the plain aerobatics with the stuff that we're working on there. Get that rolled out. And I loved that aerobatic editor that you discovered. If people didn't see that, the Open Aero one. There turns out there is actually already a web-based aerobatic maneuver editor with a language associated with it for describing them. So absolutely great looking stuff.
On that quickly, Tridge, how easy is all that stuff to transfer to like run multi-rotor style acrobatics? Like to do that in Copter? Is it all the stuff that you done there? Can it be sort of transferred across easy enough or not?
A fair bit of it, yeah. Look, I
think it's already there. Actually.
Yeah,
done.
I think you could do it. So I mean,
all of the guided commands are right there. Like I could write just if I had a scripting thing, I could literally write an acrobatic routine.
We should
guided, correct and look.
We should write set of example ones for an auto mission, including loops and copters.
Well, it's the fast descent one, which is a spiral. It's not a loop, but it's a spiral. That's done within auto. So it's guided within auto. It's Lua using guided within auto. So that works. You can't. The thing which is different is that you can't trigger it easily, while you're flying along in stabilized mode or something like that. Right. It doesn't. It's not part of any mode. It's just
the tricks on a switch.
Guided in auto.
Yeah. I was very serious about running a acrobatic routine using a Callisto.
That'd be great.
Cool. Like it would handle absolutely no problems. So if we can sort of get a structure together to do that, I can.
Yeah. TikToks for heli. I'd love it. Yeah.
Yeah.
So.
With the negative collective, we could do that in the new guided functionality that we've got for sure.
I think it'll work. I think it'll work.
Yeah, I'd love to get an aerobatic routine for helicopters. going.
And scripting might actually reopen the helical landing for planes.
Mm.
Does Pete's 6-off copter count as acrobatic? If it turns itself upside down?
Well,
sort of. Yeah.
It would be a very interesting display.
Yeah, with the right LEDs on it. Yep. Oh, good. All right. Well, I think it's probably about time that we close up. So thank you all. It's been a fantastic year. Looking forward to seeing some of you in person next year. And let's get to it and make this another great year for ArduPilot. And thank you to all our users out there who are watching the videos. We love the feedback we get on new releases, and please test the betas. That's incredibly important contribution to test our beta releases and report problems when you find them. Nice detailed problem reports with logs, really important. So thank you very much to our whole user community, and of course to our partners for helping to support ArduPilot. It's absolutely, the partner program has just been exploding over the last year, huge numbers of new partners joining, and it's been really great working with all the new partners. So all good. Thank you all for a great year, and have another great year coming up. Bye, everyone.
Thanks a lot.
Thanks, everybody.
Bye.
Cheers. Thanks.
Thanks, everyone.